to Dip A Toe.
We
How
dip
are you?
that toe. Come on, let's go and dip it, slap it,
Dip
stick
A
it.
Toe.
Let's dip it toe. How are you, Melissa?
I'm fantastic for a Wednesday.
Hump day, as per
Ah,
usual. As per usual. I gotta be honest. I'm doing good right now, but the most of the day, I don't know what kind of angry pill the universe swallowed for me, but dude, it was fully on
mm.
activation today, man. I just didn't matter what I touched, it crumbled in my hands, and I was like, okay, I need to rewind. This better not
Yeah.
be my Groundhog's Day right now.
I know. I was feeling like that a little like last week, towards the end of the week.
Mm,
I did not feel like myself at all. I was, I don't know, something was really not doing well. And some random person put a message under one of my posts and said, like, you know, I just wanted to tell you you're doing a great job and don't give up, and blah blah blah. And I'm like, didn't even know who the person was, but I thought, how wild was that? Because I really needed to hear that in that moment. And
right.
universe brought that
Yeah.
person
Yep.
to me. And
Yep.
I want to say hello. We got 42 people in here. Marvin Davis and Lisa A and Toast Man, Mr. Toasty. Welcome to the Dip A Toe show.
Dip a toe,
Uh,
dip a toe.
well,
Putting you
we
on mute.
I'm pretty excited because we have Patrick L. Riley back again. Um, and for those of you who don't know Patrick, we've had him on the show several times now. He is the CEO of Atum Industries. I think it's Industries, right? I always get it wrong. Um, and Reaper Financial. He has quite a few different projects going on. We've had him on the show before to explain each one. And he was recently, back in June, he was asked to participate in the Quantum Summit, and where he discussed his inventions that he had put out. He had put it out on the internet, um, saying, that he was releasing technology which was an immediate danger to his life. And these technologies include over unity generator, which is proven physics, he says, an ionic drive circuit, quantum helisphere, which is conceptual, and faster than light, which is theoretical. But he presented these on June 8th at this Quantum Summit 1776. And but prior to that, he wanted to release the designs so that they were free to the public to be able to go in and download them. And so he minted them, if I understand it, on the blockchain,
Hmm.
and wanted them to be spread amongst the world freely, so that it can't be stopped. Because as many of us who's done research, they've got to be just corrected me and said it's on the blockchain, and they're as NFTs, so that they're always historically will always be there forever. But so anyway, in the past, there's been a lot of people that have come up with inventions, and they turn up gone, dead,
Dun dun
disappeared.
dun.
Yes, and so, if those of you can imagine, certain technologies and inventions might actually work against the mainstream adoption of current technologies and things, where they might not want this stuff to come out. And so this is someone who came up with this and wanted to go about it in the right way before it was even out there, to have it historically minted forever and free for everyone who's interested in downloading this and trying to build these things themselves, and to also, I'm sure, to get a conversation going. And so super excited about it. I'm sure I'm gonna have lots of questions. Yeah,
Shocker.
shocker. I
Shocker.
people in here. Amen. Thank you, Jesus. That's an angel number. We appreciate you guys for stopping by. Please like, share, and subscribe to our Dip A Toe channel and share this space out. And we're going to have some other conversations too. So I'm excited to bring them in. Are you ready for them?
I'm totally ready for
Guys,
him.
you ready?
I have a question. I have a question for him already.
All right, here we go. Let's get him in here.
Let's go.
Hello, Mr. Riley.
Hello,
Mr. Patrick, how are you?
Doing good.
Good. Like the new artwork on the wall there.
Yeah, that's a X-Stick original that they did for me. I think Greg Pruitt actually commissioned that one for me about a year and a half ago. So I like to throw it up every once in a while.
Very cool. Yeah, I love it. I love all of them. All of the ones that I've seen of you guys, they're just, you guys have got some talented friends and people behind you. It's pretty awesome. It's pretty awesome. Wow. So this is going to be a different kind of show where, we're going to talk about inventions, huh? And,
Yeah,
and some other things. Nugget alert. Exactly. Angel Ramos, is that how you say that? Welcome to Dip A Toe. And our good friend Tiara is here too, supporting Mr. Patrick L. Riley. So first I want to ask you, Patrick, you went to the Quantum 1776 summit. And I remember asking you about going there on one of our previous shows, because I think sometimes Mel has a little different viewpoint on certain things. And, what did you think? I know I watched it and I thought it was fantastic, but I wondered what you felt of all the people that were there and how that went for you.
Well, it was great energy, great people. Mel did a solid job putting it together. And I really enjoyed listening to some of the speakers with some very different topics than what, most of the conferences I'll attend or speak at are about. Usually it's just strictly crypto and blockchain. This was a more holistic, humanistic type of conference where we were talking about many different aspects of life. And it was really a good experience all around.
Yeah. I was really impressed with the way that he was able to put that together. Very successful, especially I believe that I've had experience with other conferences that were online that weren't quite so good. And so I really did enjoy that. Simon, you said you had a question right out the gate from Mr.
I do. Okay. So this is a relatable question, but because of what you've created, right, and the precautions that you've taken, do you think? Okay, I guess this is a 2 or 3 part question. Do you think if people had precautions like you have now, way back when, example, the individual that created the peanut butter and jelly sandwich, would we know who did that if they had the type of precautions that we have now today versus even like 5 years ago?
Yeah, absolutely. So blockchain technology gives us the opportunity to record things for posterity for as long as that blockchain exists in time, which is why it's going to be great as we see this technology move really out of finance and into the mainstream applications of data, things like history, things like the news. Of course, we've had some controversial news these last couple of weeks, and who knows how much of that will be memory hold over the next 50 to 100 years, right, as has happened many times throughout our history. So we now have the ability to really ingrain things into an object permanence in a digital sense, as long as that blockchain survives. And of course, the XRP Ledger is a very stable and a very resilient blockchain, and I expect it'll be around for quite some time.
Absolutely. Well said.
When you say it'll be memory holds, and so Is it possible to put then videos and clips and things on the blockchain and mint them?
It is. Currently, most blockchains do have a data limit. So I believe for the XRP ledger, and don't quote me on this if some of the hardcore devs are out there. I believe it's 100 megabytes or up to 100 megabytes for the XRP ledger NFTs.
So somebody could do a little video and mint it as an NFT then? Is that understand it? So like if you wanted to try to, you'd have to make it within those parameters, like the megabyte underneath that megabyte. And so you'd have to do it in like maybe little clips or something and maybe source the whole thing so that people could see that it was real, I guess. Because you're right. I've already noticed with the past events this last week, there's a lot of additions to the story and things that people aren't talking about and all these different things, and people that say certain things and then pretend that they didn't say them. But boy, with the blockchain, it can live on forever, right?
Yeah, absolutely. It can be a permanent thing in a digital universe.
I often wonder too, like all of our history, some of the old history. I remember, and I can't remember what the guy's name is, but he kind of annoys me, but he's one of the mainstream talk show host type guys. And he had some kind of project where he had a bunch of interns saving like historical documents. And I didn't even consider that he would be trying to do that on the blockchain, because at the time that I heard that, I didn't really realize what blockchain was. I think it was Glenn Beck is actually who I'm referring to. And he had this big project, which had been going on for years and years. So hopefully whatever he was trying to do, they realized that it needs to be on the blockchain and not some other way of historically saving them. But if not, somebody needs to get on that.
And there has been recent attempts, and actually I would look to things like WikiLeaks, where of course we know with WikiLeaks there was persecution of Julian Assange for the release of what was effectively journalism from a foreign journalist, was persecuted by the United States, and that didn't turn out so great for him. And there was another gentleman who was posting university studies and paperwork, and I believe he was killed. I don't remember his name, unfortunately, at this time, but he was killed for releasing those types of scientific papers onto the internet in an open source format.
Are you talking about Aaron Schwartz?
I think that, yeah.
Yes, love that kid. Yep.
And so there's many attempts over the years, and actually one of the more interesting ones I've seen is Minecraft has a entire library in the Minecraft universe. I'm not sure who created it. I don't think it was the original devs by any means, but there's a library on there for all the banned books in all the countries, so that people who are in those countries can go into a video game and access those banned books. So things like that are a common attempt, and there's always going to be somebody trying to get that information out there and make it publicly available. With blockchain, that's exactly what it does, is it cements it in an NFT format. It's coded onto the blockchain, and to take it down, they have to take down the entirety of that blockchain. So with my inventions, what I did was I put my designs on more than a dozen different blockchains. I've only publicly released a few of them. But what that does is it makes it so that if I was a target, if I was killed or arrested, or I became a subject of that type of persecution, now they're just drawing attention to me. Well, everyone has the ability to publicly go and look at these designs and see for themselves what it's about. So I've kind of made it difficult for governments to do much about it. And the other side of this is I have not patented any of these designs. I've completely open sourced them. If you do patent anything in the United States, due to the 1951 Patent Secrecy Act, you are asking the government's permission to release your intellectual property at that point. And they'll approve the patent, and then they'll slap it with an NDA or National Defense Act restriction, and say that if you speak about this or release it or build this, that it's a violation of the National Security Act, and you go to prison for life. And that's that. Wow. For essentially espionage charges. So I'm not asking the government's permission, and not giving them the opportunity to suppress this. And I've made it so that if they do suppress me, it will only cause more thorns in their side. And of course, I do have dead drops as well.
That's it. We want to welcome in the new Mindset and Joe Schmo and Bones, Indie Odyssey, and Keita's here, and K Buddy's here, and Crypto Ace is lighting up the chat in there with his chit chat. Welcome, guys. So, yeah, that the fact that you did decide to do this in this way does kind of protect the information, right? I mean, I'm sure it can really piss some people off.
Yeah.
Gotta be wants to know what are in your dead drops. Just kidding.
So I'll answer that to an extent. So in my dead drops, I although I've released these 4 technologies that I've designed, I do have an additional 30 or so designs, and a few of those designs in combination would allow for some very disruptive things for really everybody in the world. And it would be really much more of a problem than free energy or electric rocket engines, or even all of the rest of phase 12 that I'm about to explain. And it could be done very cheaply by just about anybody. So it would be a double-edged sword. It's not something I necessarily want out in the world, but if it ever comes to that, if I am no longer able to renew my dead drop servers, basically, to ensure that remains hidden, then it will come out. And that will be problematic for not just the government, but everybody.
Wow.
So everybody support Patrick Riley, because we like the life the way it is.
I'm wait a minute. I'm like, back up. What do you mean it'll be bad for everybody?
But that's on a serious note. You do have to take those type of precautions at that level. Yes. Very, very much so. As you explained, would you say 1951, right? 51?
Yeah, 1951 Patent Secrecy Act.
Yeah, Patent Secrecy Act. Yes. I mean, you have something like that in legislation, and then it's kind of just a blanket, do whatever the heck they want to you, type of a piece of paper. Anybody that creates anything that's disruptive, that has the potential to be disruptive, and that's not in a negative way. It just means that it changes things how they are, which would be a disruption. That doesn't boast well with their position. So you have to. My word is respond to that, because if that's in play, you are responding appropriately to what's been presented to you. And it sounds like you've done a very good job of responding appropriately to ensure not only your existence on this earth can reach its full measure, but so does your creations that you have shared with all of us here on this earth, and the ones that have yet to be here. So I thank you for that.
Yeah.
Thank you.
I'm excited to learn more about them. And before you start explaining them, for those in the audience that are either watching now or going to watch this in the future, because I'm banking on it that people are going to be watching this later on down the road, once your ideas really get out there, and they're going to want to see all kinds of different interviews with Patrick L. Riley. So I wanted, if you could just give a quick little refresher as to how you came to invent all of these things, and did you do this all yourself? Are you working with a group of folks? How did Patrick L. Riley become an inventor?
Yeah, so this actually kind of goes back to 2009 when I had a TBI, or a head injury from being blown up in Iraq. My TBI caused me to become what's called an acquired savant, or savant syndrome, which basically means that when I had a head injury, my brain tried to heal, but in doing so, it created new neural pathways and new nerve endings within my brain through a process called neuroplasticity. And I became a little bit smarter than I was when I first entered this realm or this planet. So I came back from Iraq, and I started inventing, and I started understanding systems at a kind of a exponential level and at a almost instantaneous level. So things like automotive mechanics, anatomy and physiology, universal or astrophysics, finance, and even to a much larger spiritual level, if you will, concerning consciousness. So in that time frame from 2009 to now, I started inventing, and of course, knowing that these inventions would take funding and take significant work and action on my part, I started planning and plotting how I was going to get there in the long run. And of course, Reaper Financial and Ascension Index, Atum Industries in general are all a part of that grander plan to get us to where we need to be, so that these things can be a reality.
Wow. That's incredible. I mean, really, your story is very interesting. Just the fact that, you had such a traumatic thing happen, and to come out of it and then actually be smarter, that had to be somewhat surreal when you first discovered that you were retaining information at a rapid pace, and you're like, what's going on here?
Yeah. So I was talking with my fiance yesterday about how I could describe this. And the best way that I could describe it is there's a pastor out there by the name of Mark Grunger who talks about men's and women's brains. And that the tale of two brains is the TED talk he gave. And basically with men's brain, you have the point-to-point communication, and it's very linear, and you have boxes, and everything is in a different box. So in those boxes, men have like a nothing box, or some men have a nothing box, and whereas women, it's kind of all connected, and it's connected by emotion. And he gets into this whole thing. My brain works in a way that everything is in its own file folder or its own categorization, but each of those folders can exist in superposition in other places in my brain all at the same time. So it's kind of like if I were to, the example we were talking about was apples, oranges, bananas, and grapes. Now, those can all be in the fruit box, but it's at the exact same time, they're all, of course, going to be in everybody's different color boxes. But for me, I've also got them kind of in a, I've got my potassium of my banana off in my explosives box, and I've got my citric acid of my apple and my orange, and I've got like this entire thing all existing in many different places. And any file that I would want to access, it's kind of like if you opened up a file on your computer and it wasn't just what you had put there directly in that file path. Instead, it automatically knows that you've opened a file related to this, and the AI has aggregated all the data that could possibly be relevant to that thing into one location, and it throws it at you in a way that you'll immediately understand. And it's kind of how my brain tends to work.
Damn, that sounds like there is an invention that I heard about recently where they put it like in the bone, like by your ear or something, and it's supposed to be
Neuralink.
Yeah. Oh, is it called? Well, I thought it was called something else, but I guess it is the Neuralink thing where you don't, it's just like in your mind, and you think it, you it's just there, the information's there, and then you speak it like in real time, like a computer in your brain. Like, so what you're describing is like you're looking at all the files on your computer, and you have them all, you know, associated with different things, and you can just grab it, and it's all there, and it all makes sense to you.
Yeah, it's kind of like a planetary file system working in some sort of quantum format where I don't have to try very hard to look for anything. It's just immediately available.
Isn't that, I mean, I know we're going to talk about your inventions and all this, but like this is pretty damn incredible. I mean, this is, you hear of people, well, when I used to smoke pot, I did a couple times. I remember sometimes I would get real deep thinking about the things that I might not have given attention, were just much more, I was much more into it, and I was coming up with ideas, and making connections that maybe I wouldn't have made when I was not high. And then I've heard of people, you know, doing mushrooms and things like this, and they get these experiences, which I would never, I'm like too chicken to do anything like that. But in any event, that was my way younger days.
Well,
I don't really do it now.
yeah, and I never did any of that till I got out of the military. But I am a amateur legal psychonaut as far as what is legally available. I've tried, you know, THC edibles, and tried mushrooms and DMT. So, you know, the actions going on in your brain when you are under that type of influence is essentially connecting those additional neurons, and you have that additional understanding or vision that you wouldn't normally have. So that is kind of like a temporary savant syndrome or synthesia syndrome in many cases. So for me, it's kind of like the brain injury did connect some of those things, and they just stay connected. Whereas for other people, that is a temporary state.
Mm-hmm. I would agree with that.
I wonder, because once you realize that you're getting smarter, and I'm sure that causes the chain reaction of, well, what else can I retain? It is kind of like you're expanding your thinking in your mind, and then the more that you learn, the more that you want to learn, because it's happening for me. Since I've really focused my attention on learning things and asking questions, and, you know, talking with a variety of different folks from different perspectives, my vocabulary has increased. Just so much, I've improved so much. Like, that's my goal, is just to continuously improve and talk to people that are smart, or that I think are smart, and even talk to some people that are dumb because I think I learn from them as well, you know. And so, but for you to have this happen, this miracle happen, and the fact that you're actually taking advantage of it, it is pretty remarkable. And I mean, was it scary at all, or did you just embrace it?
Yeah, I wouldn't say scary at any point. I didn't fully understand it until I read a book by another acquired savant in 2014, a man by Jason Paget, who's wrote the book Struck by Genius. And that kind of helped me relate to it, and then understand and put it in perspective that this was what was going on with me. And that also, that same book kind of inspired my path down psychology and forensic psychology, and eventually ending up in PsyOps and my study of consciousness, because I understood intrinsically after reading that book the systems that made everything that happened to me and him through acquired savant syndrome possible.
Wow. Simon.
I can relate to what he is explaining in the temporary zone that he described previously. There's been many times that me and acquaintances or friends have partaken of the sweet Chiba, and we would have, it's not like we didn't have any good ideas. It was more like the good ideas were behind this wall per se in our minds. And when we would have, have that, and all of a sudden that wall was gone, temporary, but nonetheless, I mean, we were on fire. We wrote down our ideas that we had of maybe how to fix things, great ideas, anything like that, and we even like, all right, when it comes to food, first we were like, oh, this is really good. But that's how the conversation starts. Why is this really good? What's in this? And then all of a sudden you're on a knowledge quest in your in your 4-hour journey with Mary Jane. But in that moment, or in those moments, you don't really, or at least I didn't, you don't really have that, why am I so smart right now, or whatever, how come all this information is, you're just in that moment. Later, however, you make correlations to that, and I would imagine that happened within a nanosecond with Patrick here. I was describing it. Why am I? Don't have an answer yet. He got his answers in a book, and it made sense like that. And for most of us, we still have this wall somewhere in here. Neurons are not connected all the time, right? So, but the question still remains: how come I can with this versus how come I'm unable to without? And that's been a very interesting question of mine personally, because I've done a lot of sciencing with just THC, medical stuff for my wife initially. And I know we're kind of going off the rails here a little bit on topic, but it's totally relevant. What I've noticed in my own journey with this is I have found specific strains that I have that allow what I would call my disabilities to take a back seat. Okay, that's my word for disability. The things that a part of me that gets in my way, and it's removed enough to where I can recognize, okay, it's removed. Now I can do these things, and etc. And then of course, the after my partaking's over with, the next day, actually it's usually about 3-4 days after, then I start to kind of go back, what I would call, to the old me, if you will, or just my normal thought process. My roadblocks are back, but within that 4 days, I noticed that I'm able to handle a lot more real world BS, in my opinion, in my words, at once. And my response to that is very calm, very calm. And it was my wife who actually really kind of brought it full circle, because I'm in my own head. I'm like, I don't trust myself. Shut up, you do too. No, I don't. Blah, blah, blah. It's like this ongoing conversation, right? So here I am listening to Patrick right now, though. I've had those thoughts and thought processes for years. He had it in like 5 minutes. Okay, he had arguably, the Matrix move, in the back of the head, upload the information. Oh, we're good. Wow, how was it? What a rush. Let's do it again. Got another book? A
little bit like that.
A little bit like that. But there's this point where, because it made sense, it totally removed the emotion off the table. And I've experienced that over time, slower, arguably. But it's very much there. I wish we could just connect all our neurons. That'd be great. Probably be a little bit better place to live. Maybe. I don't know. Yeah, well, we still got desire in there, man. And sometimes even, a couple of potheads in the kitchen, sometimes there's a little beef of what to make, and it's an ongoing
some great
debate.
Food
I know you can, but it doesn't stop there. It doesn't stop.
Yeah.
That's a classic example of I need to get a good idea. Okay, let's go out in the garage for a minute. Okay, let's come back. What do you want to do? So anyways,
I just think it's pretty cool with you, with the fact that you are able to retain something so quickly, and then it stays. And if I was around you, I'd probably be testing you all the time. I'd be like, read this. Well, what do you think about this? I'd be like constantly, what do you think, Patrick? What do you pay? I'm like, I got your number and I got your thing, and I'm like, don't ask him any questions, Melissa. Don't be the weirdo that's asking him all these random questions on the internet. But I think so.
Person.
I'm super impressed with just even the fact that you've got this now. You're learning all these things, but you're wanting to give back to the world. These ideas, these inventions that came to you, and the fact that you've been so bold with it, and putting them on the blockchain and minting them as NFTs and sharing them with the world. I wonder, has it been well received yet? Are we doing a good job of trying to spread the word? I think we probably got a ways to go. But are you getting feedback from folks on these inventions?
I am, and I've only had positive feedback. I haven't had anyone come out with any kind of nonsense. Nobody has brought any kind of logical argument to dissuade or disprove anything I put out, and I don't think there is one. But I did have an invitation from Carrie Cassidy to go on and do a show with her, which I did about a week ago, and that was very well received. I've got quite a few emails from her audience requesting the plans and requesting more information. So I'm very grateful for that contact. I will be on again with her on the 26th, so that should be good as well. Yeah, it's really been a great experience, but we definitely have a long ways to go. I've got to keep pushing. I've got to keep putting these concepts and ideas and plans out there. And we need people building them. Ideally, what I would like to have is between 1,000 to 10,000 people out there with working prototypes, building these for themselves, so that at that point we can be more official in the way that we go about talking about this, because there is so much to fall back on. Versus if I build a prototype and I say, here it is, that doesn't really mean much in terms of internet and credibility and logistics and keeping it out there. So the idea is I want as many people as possible to adopt this and to build this technology.
Yep.
And this is something too, like this is part of the crypto digital asset space, the future, whatever you want to call it. It's not for sissies. It's a do your own research type of thing. And how you're going about this is not, we're going to do this for you. You're expecting people to have enough interest, look at it, and try. That's all you're asking them to do, is try
Exactly.
to do it. Right.
And I'll say that it's absolutely worth it. And even if you're only going for one of these technologies, achieving any one of them, even if you're building it yourself and, it was maybe my design or my idea, that doesn't mean anything. You achieving it is a great achievement. If you achieve a free energy generator, essentially an over unity generator, you're going to be able to do monumental things with that in your own life that are going to make it well worth it. So that's where I'm appealing to people. If you wanted to, for instance, mine cryptocurrency or Bitcoin or Litecoin or Ethereum, I guess not Ethereum anymore, but if you were going to do those things, you're going to consume quite a bit of energy. And if you were trying to bring that cost down, this is a great way to approach that. And the tooling and the cost of building one of these is not exceptional compared to the cost of a few miners.
Could this be a homeschool project? Like, could you? Is it safe enough for? I mean, this is what's popping in my mind. I'm like, shop teacher project for kids, homeschoolers. Hey kids, this is what we need to buy. This is what we're going to build. And how freaking cool would it be if you had a bunch of 10, 12, 15, 16-year-olds building this stuff and succeeding? Do you know how empowering that would feel if they were actually able to make electricity?
Yeah, absolutely.
themselves. I mean, so sorry, Simon, I cut you off.
No, I'm gonna interject on that, because what you're talking about, Melissa, that hey, I built something. Okay, I'm a little biased, but that's because I'm a tradesman, right? We build stuff. I with a great many hundreds of thousands of people in this country alone, we build America. We build buildings. We build machines. We take something in its raw material, we make it a pliable material. Then we take that material and we eventually get to something what Patrick has designed. So for the homeschoolers or the any 10, 12, 13, 14, 15, 16-year-old kids, yeah, get out there, get your PPP on, get your welder's hood on, get a tape measure, and start doing it, because that is gone, relatively gone, right? That building, that creating, using your hands, that is gone in the way that it used to be. I guess idolized maybe in like the 40s and the 50s and the 60s,
And I'll say it's coming back, because
yes,
AI
yes.
is going to wipe out all the data entry jobs, all the telemarketer jobs, all the customer service jobs, all the most of the internet and
But
tech
I
jobs.
can weld, baby. I get my hammer out and I'll build something.
Exactly. So manufacturing is, robotics will be a thing, but
sure,
actual making of handmade products is going to make a comeback in the next 50 years in a very big way.
Mm-hmm.
Well, totally going to redo her basement and make a shop now.
I mean,
like, but I mean, I think if you just think of like how what people find attractive or what they like is things that are different, unique, and that sort of thing. And so as we move towards a more robotic, automated world, I can see hand-built items being sought after because they are unique and, a different, so to speak. And so, and again, like, I'm always the optimistic type of mind. I want to put that out there, is that, just because we move towards this direction with automation doesn't mean that it's going to be all doom and gloom and terrible, because like you're suggesting, there are so many ways that we can do better and build things and contribute. Growing your own food, learning how to can it, building your own bench in your backyard, whatever it may be. We can all contribute to that, and be happy too. That's the other thing, happiness.
And
So
it should always be the goal, is quality of life. Like, there is no reason our society or any person as an individual should ever be working towards anything that doesn't better their and their family's quality of life.
Amen.
Well,
what do we say we dip our toe into some of these inventions?
Right.
I'm
ready to build. Let's bring it out. I'm ready to build.
389 people watching right now. Thank you so much for stopping by Dip A Toe. I did want to say that we have Crypto Professor. Shout out to Crypto Professor and Indie Odyssey. But so without further ado, let's talk about some of these technologies. If you guys put it in the chat, if you want us to make this full screen or if this is good enough, let me know how you want to see it on the screen. There we go.
Yeah, let's do that. All right. So now at Quantum Summit, I'm using the same slides here, but I presented the 4 different technologies and 2 specific use cases. There is infinite use cases for these technologies. Now, as I mentioned before, they're open source, unpatented, minted to the blockchains. Now, I know last couple times we talked technology, we breezed through it pretty quick, Melissa.
Yeah, way quick.
I'm going to try to slow this down. I'm going to try to allow for questions so we can kind of deep dive this.
Love it.
And y'all can ask whatever you like. That slide didn't didn't apply. First technology is the Riley radial. So I'm going to zoom in on that. So now the Riley radial is the body of the device as I had settled on it. So in 2009, after I had my head injury, I asked a real simple question: how do I get force without an explosion or exhaust in a motor? And the answer is electromagnetism. So this body with the blueprint shown here is 30 centimeters in diameter. It's 29 centimeters from this outer edge that I'm circling. I don't know if everyone can see my cursor there on the screen. Yep. And it's 21 centimeters at the center as a center hole. And then we have 4 centimeter piston clearances in 8 different piston clearances in a rotation of 45 degrees each. Now, around each of those piston clearances, you can see a little box in there. That little box is for a permanent magnet to be inserted. And then you'll also notice these little dots here. That is just basically screw holes for assembly. And those are half centimeter or quarter centimeter, depending on what type of screws I happen to have in my toolkit at the time. Any
Can I do it? I have some questions already.
Yeah, go for it.
So first one question, it kind of piggybacks on mine, so I'm going to let them ask it. Boone asks, would this radial replace our everyday vehicle engines?
It certainly could. You would still want to have some form of battery and some form of electric motor to specifically drive either the transmission or to drive the wheels. But it could certainly power it and replace regular vehicle engines.
Okay, so immediately when you started explaining this, I was like, okay, I guess I have to back up with the reason for this. You're building a motor, basically, right? This is the beginning of building a motor.
Yep.
And you why? And I guess for those people that don't know even how a motor works to begin with, for you to even ask that first question, how do you get force without an explosion or exhaust in a motor? What does explosion and exhaust do in a motor to begin with?
Yeah, so usually, and I kind of started with V8s. Like I said, I got back from Iraq and I started building cars from the frame up, and I liked the Chevy 350 because it was the most common block ever made in automotive history, and it was also pretty awesome to stroke one out 30 millimeters to a 383 stroker, which is technical. You don't even know what that means. Basically, as I started building motors and thinking about the way I could improve upon the design, with a standard V8, you have your pistons canted at a 90-degree angle to each other, 4 on each side, and on top of those pistons, you're going to have your I'm losing the word here, your piston heads, as well as your spark plugs and your fuel injection. So your fuel injection goes into the piston chamber, your spark plug ignites it, and that pushes the piston down. The piston is connected to a rod, and that rod is connected to the crankshaft, and it causes rotation. That rotation is connected to either your flywheel or your clutch, which is going to drive your transmission and move your car. So essentially the entire point of a standard V8 motor or a standard car engine or any engine or motor is just to cause rotation. That's what you're going for. You just need something to cause a sustainable, powerful, high torque rotation. And that is what is going to cause you to be able to move an automobile or to create electricity. So most cars use a standard alternator, and I do have a slide of a regular alternator in here later. But basically, whether we're using nuclear power or hydroelectric power or wind energy, pretty much anything but solar, you're only really creating energy by turning a permanent magnet within a copper coil. That's it. Like people think the nuclear energy is coming from an actual like nuclear reaction, but that's not what's actually doing it. They're using the nuclear reaction to heat up water, and that water is creating steam, and that steam is still turning a turbine, just like if you were running a turbine on a dam and hydroelectric power. So rotation is really what this is all about, to create electricity or
Thank
to create
you. Yes, thank you for explaining that, because I kind of I get it. I get it much better now that you've explained it in that way, just to even understand why you asked that question to begin with. As far as, you know, why you would need how you could get force without explosion or exhaust in a motor, because the exhaust, like Ryan has said, like up at the university there, they have like a reactor that they use waste to create the steam, to boil the water to create the energy, right?
Yeah.
And then I've heard people debate on, you know, this energy, different kinds of energy sources where they don't use, you know, they think they're not using any kind of gas or coal or anything like that, but they really are, because they're doing that so they can boil the water, right? It's all about that, getting that force.
Exactly. And that's really all it comes down to, is creating force. So how do you create force and use that force to enact a rotation? Which is why I ended up settling, instead of a standard V8, which is kind of where I started, I ended up settling on this circular design, which is a radial design, because you have a full rotation. And that means I have more opportunities to apply force, and I don't have any you know, pushback or friction or opposing torque forces.
Oh, okay. So now that you explained that, can you explain again where you're talking about the circular, where you've inserted the magnets into these different holes?
Yep.
Yeah. Can you explain that?
It'll make a little bit more sense with the next slide, I think, here. So now this is just your standard dipole magnet, and it's a permanent magnet. There's no electricity applied to a permanent magnet. It simply has a permanent magnetic charge that can last, you know, hundreds of thousands or millions of years. This is your magnetite or your iron ore magnets, or your ceramic magnets, neodymium magnets, things of that nature. And if you apply a North Pole against a North Pole, or a South Pole against a South Pole, you get what's called magnetic repulsion, which is that they force each other apart, and they do not allow those two magnets to make contact with one another. Now, this is a very normal thing. This is not anything that's crazy, science-y, anything. So if you don't believe me, find two regular magnets and turn them until you can't put the two sides together, and that's how that works. So this is a very basic design or depiction of magnetic repulsion. And there isn't really any such thing as a north and a south pole. There's just the orientation of the electrons, but we don't actually need to get into all that depth of it.
Sure.
So now let me go to the next one here. So on this one, you can see that I marked some of this as red. So the areas marked as red, including these slots that are around the piston holes, these are where we would be putting permanent magnets. Now, those permanent magnets, like I said, they are not moving by themselves, and they are not causing motion. They are simply causing magnetic repulsion from any other permanent magnet that has an opposing pole to it. So in this case, with the bottom of the design here, you can see I had put basically a base plate, and I dropped a lower half of the crankshaft into that base plate. Now, the base plate has a permanent magnet at the bottom, and on the bottom of the crankshaft, there is a permanent magnet opposing it, so that crankshaft is basically floating over the base plate. And then we also have a permanent magnet sitting attached to the top of that partial crankshaft. And then you have those permanent magnets that I talked about earlier, which are inserted around the piston clearances here. So
can I ask a question about magnets?
Yeah, absolutely.
So this is I like there are no dumb questions, but are there different kinds of magnets, or like where would someone get a magnet like this, and can you just use any magnet? Or
so there are all types of different magnets that you can get. You can go on Amazon, or you can go to Home Depot or Lowe's or Ace Hardware, and you can get different types of magnets that are, you know, iron ore magnets, or you can get ceramic magnets, which are usually some of the cheapest and most efficient for this purpose, or neodymium magnets. I will say that if you're trying to build this, neodymium magnets are hard to work with when it comes to cutting or shaping because they're very brittle. So you probably don't want to go that route. A ceramic magnet, however, in a simple CNC machine, such as can be purchased on Amazon for a few $100, those ceramic magnets cut relatively easily and they shape relatively easily. And you can also get a magnifier, which basically passes a current through whatever you attach to it. That would remagnetize any piece of metal that happens to be iron or a ceramic iron composite, so that you make sure you have the right orientation based on how you cut the magnet if you had any problems there. So that's that's a few $100s spent, but you would be able to purchase these magnets essentially over the counter from multiple different hardwares or sources. And really all you need is something big enough that you can cut it down into the shape and size that you need.
What would you use to cut such a thing, like such a magnet?
The CNC machine. So I prefer something off of Amazon here, which is a very simple metal CNC machine. And I'll actually pull that up and share it just so that I'm not being a little bit obscure here. I want people to see exactly what I'm talking about. So let me switch to a different screen. Share screen. All right, so this is just Amazon here. If you can pull that out. Yep, so this is just Amazon, and here you can see there's plenty of options, but just a cheap CNC machine such as shown here for $400, or there's even smaller ones for $150. These could be used to essentially secure the ceramic magnet or permanent ceramic magnet, and using the right bit, you would just put it into a computer program, a 3D CAD program, that you mapped out what size and shape you need for that that magnet, and you could run it through there and it would cut it for you, and your part is ready to go.
Okay. Interesting.
Now,
Darren Baxter says, even without friction, could there be heat generated from the rotation of the main crankshaft at high RPM?
That depends how high the RPMs are. The easy answer to that question is yes. The more realistic question to that answer is that you would need to be at many hundreds of thousands of RPMs, whereas a regular motor typically runs up to 10,000 RPMs. A Formula One car runs up to 15 to 18,000 RPM. So this is going to run a very high RPM before you would ever encounter any kind of heat resistance based on the magnetic repulsion. You would, however, have winding resistance in the alternator, and that is going to be based on your material sciences and basically your construction methods. So, of course, if it is getting hotter at a higher RPM due to winding resistance of the alternator, and I know I'm getting a little technical, so this might go over people's heads, don't worry about it. Essentially, you would be able to create a system to gap that alternator further from the winding resistance so that you lower that temperature should it get up to that temperature, but then you may be creating less electricity. That all comes down to tuning and the material science properties.
Right.
Some folks asked if you could Some folks asked if you could share the link for the magnets also.
Yep.
Yeah,
So
yeah,
there's many.
Oh, sorry.
Yep. There's many different options there, and I would say you are going to have to shop around a little bit. But my primary source I would use is Granger. Granger is an industrial supplier that is available throughout most of the U.S. If you are outside the U.S., I apologize. I don't know the best places to source things for you, but you would have to do a little bit of research and find comparable places to shop.
And the machine to cut it, you called it a CNC machine?
Yep,
CNC.
CNC Cat Nancy Cat.
That's
machine.
right. Yeah, cat.
Okay.
Cat.
All right.
Yep.
All right. Sorry, Simon.
Oh, it's okay. A question on rotation.
Yep.
How can you first off increase the rotation?
So
how would that be done?
We'll kind of get to that, but I don't want to answer that yet. Just
okay. All right. A little premature. Shocker.
Yeah.
And then one other thing is so the beginning of the first slide that you were showing, the actual all the pieces are to that. How does one get those types of pieces? Like what are they? What are they looking for?
Yeah, so if you want to pull up the slide again there, I'll kind of so I can point that out. So yeah, if you were trying to get this body or you were trying to do the base plate, so you could actually build these out of almost anything. You would just want it to be non-magnetic so that you're not interfering with the permanent magnets or the rotation.
So stainless steel, like stainless steel,
or
tungsten.
Yep, aluminum would actually be kind of the preferred cheap source.
Yep. And it's a good heat resistance too. Yeah,
yep.
Makes sense.
And alternatively, you could 3D print this in many different materials, PLA, PGA.
Yep.
Now, if you do 3D print it, I will only caution that there is warping that can happen with a 3D print, and that's just based on temperature, not necessarily temperature produced by the motor, so much as temperature ambient to your print. So you may have some dimension issues if you do that. But as far as just prototyping, I highly recommend doing it on a 3D printer first before you go and CNC a 30 centimeter block of aluminum.
Could you do it with wood? Darren Baxter wants to know if you could do it with wood. And then he says wood warps, which is true.
Yeah, you technically could do this in wood, and various different types of wood could be practiced with. Wood warps differently depending on the grain and depending on the type of wood, or you've got your hardwoods and your softwoods and your very dry woods and your very wet woods and things of that nature. I am not a carpenter, but I'm sure if you are a carpenter, you would probably be able to choose some heat resistant wood that would be a good fit for this application.
So back to the dimensions real quick. We're talking basically like 29 inches wide OD or outer diameter, and then
right. So I actually do it all in metric.
I mean 11. It's 11 and you did 29 centimeters, so we're talking almost 11 and a half inches outer diameter, correct? Right.
Yeah. So it's not very big in this, but this is completely scalable. So now, of course, I designed these in a 3D CAD program called ShapeR 3D. With that, you could simply scale it to any percentage of what you want. And if you could build this small enough to go inside of a wristwatch, obviously a wristwatch has many complex moving parts. And if you're someone that manufactures wristwatches, you would probably be able to build this design into a wristwatch and make it effective. I don't have anything to tool at that scale. So I've chosen this scale as the most easy to work with for my purposes. But it all depends on what you want to apply it to.
Okay. Yeah, I was just curious about the initial size, but general workability.
Yep.
Easy to do at home. That makes perfect sense. No bigger than 12-inch round. Easily to work with. Small enough to be small, but big enough to still be able to uh, see how things work and function before you scale up or scale down. Um, well done.
Yep.
Continue.
All
I'm
right.
taking notes.
All right. So now on top of that partial crankshaft, I have a rotating assembly. Now remember that the partial crankshaft had a permanent magnet on top of it.
Mm-hmm.
So the bottom of this rotating assembly, which you can see over here on the blueprints, also has a slot for a permanent magnet, which is an opposing force. And so it is free floating again without friction on top of this portion of the crankshaft. And then we have these 8 vertical pylons that will also be surrounded by permanent magnets.
What's a pylon?
These vertical posts that are on the rotating assembly.
Boone wants to know, how strong of a magnet are we talking about?
So you're going to want the magnet to be strong enough to hold everything in place. And then you're also going to want to consider the weight of the material that you use in your rods and your pistons, so that you know how much torque you're putting into it at what speed, so that essentially you're not hitting those magnets against each other. The idea is to make it rotate freely without ever having any kind of friction or contact between any of the opposing magnetic forces. So
I'm sorry. Oh, sorry. I was going to say, I'm sorry. Crypto Ace has a question, but I can't find it.
He wants to know about Banca, but it's not really relevant to this conversation. I
didn't see it. Okay.
Wah, 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 wah.
Another
Sorry.
base.
Okay, sorry about that. Okay, so the pylons, and I'm sorry if I missed this because I was looking for the question. The pylons in the red, are those magnets around the pylons?
Yep. So you would have a metal core here that can accept a round cylindrical magnet over it
inside the shaft. Yep.
How the heck do you get I've never seen a magnet with a
so that is why it's important to be prepared to machine or CNC cut your own magnets and your own shapes, because if you don't, you're not going to have an easy time completing this design by any shape of magnet that currently is market ready and available. They're generally just not very accommodating for this application. So you will want to make a more custom fit, which means you're going to want to have a little bit of tooling available to you.
Could you you could buy those round magnets like that, could you get the round magnets and then like punch a hole through it if
you wanted to try that, as all things with science and manufacturing and do it yourself, just be prepared to fail a little bit. But
I mean, I was just thinking, like, you could get those round ones, and then even if they weren't as thick or as deep as you needed, like you could like stack 1 or 2 on top of each other.
As long as you're able to achieve the principle of having a cylindrical magnet that gives a force in a outward direction, and putting another cylindrical magnet around that gives a force in an inward direction, then you've achieved the intent, essentially.
I mean, already I'm thinking to myself, if I'm going to try to build this, my first challenge is the magnet, and because if you can't make these magnets to go on these pylons, then that's like the first step in my mind of what I need to see if I could even do it, to make the magnets.
And it's probably every dad's trope out there for his son, but the right tool for the right job. So I'm not saying you can't do it by punching holes or other things like that, but you'll probably be best served to be prepared to, spend the money on the tooling that will do the job certainly, and then do the job as concretely as possible from the get-go.
So what tool would do that then for to make
the
the
CNC machine would be the best for this.
Oh,
purpose.
okay.
Yeah.
All right. So that same CNC machine can make this kind of magnet. All right. I thought that was going to have to be something separate. Okay.
Yep. You can certainly do all the magnets for this design on a single CNC machine like that.
Awesome.
Mm-hmm. Mm-hmm. Yeah.
Okay.
Not bad for $400.
Yeah, not bad at all. So going on to the next one. So now I added a few different visuals in this single slide here, but essentially what we did was we took our piston rods. Our piston rods are connected through a shaft there to our pistons themselves. And those piston rods are being placed over the vertical pylons that have those permanent magnets. Yep. And there's a permanent magnet inside the piston rod. And this is essentially replacing what is a bearing in a traditional engine with a magnet. Not to be confused with magnetic bearings, because that's a different thing. There are magnetic bearings out there, but they do make contact. They're not friction free. So just to make that clear, you're making your own magnetic bearing that has full magnetic propulsion and no contact.
Okay.
Now, then you're going to take the second half of the rotating assembly here, and you're going to connect that to the lower half of the rotating assembly. And then you would drop in the upper half of the crankshaft through that upper half of the rotating assembly. Now, you'll notice that the lower half of the crankshaft has a square vertical connector. Of course, that means square peg, square hole in this case, and that minimize rotation. And then you'll also notice that the crankshaft coming vertical from the second half, it's turned at 45 degrees. And I'll point out why that is in a little bit here.
Okay.
Now, on the pistons themselves, we have a piston ring, and we have a flat disc permanent magnet at the tip of the piston. So now, at this point of the motor, we have nothing electrical added to it whatsoever. This is simply permanent magnets and whatever base material you've used that is non-magnetic to provide a body, crankshaft, rods, piston, etc. Most likely aluminum if you're trying to do a more professional build for this. So we're only looking at aluminum and ceramic with a little bit of ferrous material in it right now. None of that is rare. None of that is hard to obtain, and none of that is hard to tool if you have the right tools. Any questions to this point?
I don't see any other questions in the chat right at the moment.
Okay. And I will just point out there is a piston rod clearance along the center line of all these pistons to allow for that rod to have full rotation without any kind of interference or friction.
Gotcha.
You'd have to make those you call them the piston. You have to make those too, right? So you'd have to. Can that machine do this? Make that as well?
That's correct.
Okay.
Yeah.
Okay.
Now, once
Sorry. Go ahead. Sorry.
Did you want me to go back to the last one?
No. I was gonna touch on the CNC machine. Like, I was just curious if Melissa, you've seen any type of machine cut out a pattern.
I really haven't. That's why I'm kind of fascinated by this whole. I've heard of like 3D printing and all these things, and I don't really understand what that even is, to be honest with you.
I'll show you. I don't know if you want to switch the screen there, but I got a couple. My whole closet of my office is two 500 millimeter 3D printers over there that do a lot of work. So.
Oh.
Yeah, and the CNC lives in the garage, but it's messier.
Yeah, it is.
Simon knows. So once we've got it to this point, we're now putting the top plate on for this module, right? So we've got our closed module here. And we've put piston sleeves on. So the ring that is around the piston is creating magnetic propulsion against those permanent magnets that were surrounding each of the piston clearances. And then as the piston ring and the permanent magnet on the end of the piston goes through the piston sleeve, it's passing through a copper coil.
Okay.
How are those attached? Are they like threaded to the body?
Threaded.
Or
I'm actually using regular screws. Basically, that's what these little holes that you saw around the body were for. Is those are the holes to accommodate for inserting screws or
mounting,
mounting bits. Yep. Now at the end of these coils, I'm using this one pictured right here, which is a very small 35 Newton suction. You'll note it says suction on it. Electromagnet, but essentially what an electromagnet is you're taking a ferrous material and you're wrapping it in a conductive wire and you're sending an electrical signal through that wire, and that causes the ferrous material to become more magnetic. And in this case, it would pick up the paper clips, assumably. So with this, that's all packed into this tight little made in China or Taiwan electromagnet that I ordered on Amazon. I think these cost about $6 a piece. And I've put it into a cap that is at the top of each piston sleeve. So right now there's still no electricity being added to the system or applied to this system. It's permanent magnets, it's copper coil, and it's an electromagnet, which is basically a permanent magnet with a coil around it as well. Now, this is Faraday's law. Faraday's law basically says that when you pass a permanent magnet through a copper coil, you induce a current so long as that permanent magnet is in motion. So you can increase the current in the coil by using a stronger permanent magnet, if that's what you need. You can increase the motion of the magnet, so basically the speed that the motor is rotating, or you can increase the area of the number of turns of the coil. So what they mean by area is the gauge. So you can take a very small gauge, a very small copper wire, and you can wrap it many times, or you can take a larger wire and wrap it less times, but your number of wraps times your gauge is going to equal the current that wire can handle, and it can send off to the electromagnet in this case. So Melissa, do you get kind of where I'm at with that? If we pass,
I think so.
Okay. So, and just to be clear, this is not this is not something I made up. This is a accepted Faraday's law equation that is a standard part of known physics. I haven't done anything outside of physics. I haven't suggested anything outside of known and applicable science that we have today. So now here's kind of the whole trick of how this works and why it works. So the firing order for this, and you can see there's the crankshaft in there, right? But as piston 1 is passing through the piston sleeve and the coil, using those permanent magnets through this copper coil, this copper coil is not firing the electromagnet that's on top of piston 1. Instead, it's skipping over to piston 3 and it's firing this electromagnet. Because it's firing this electromagnet, if I go back here to show kind of the rotating assembly here. So, okay, so 1 fires and that fires 3. That's going to pull this piston and the permanent magnet that's at the end of this piston in this direction. It's going to pull it to the far right. So as it pulls that one towards 3, passes through this coil and then pulls 5. As that pulls through 5, it passes through and it pulls 7. As 7 passes through, it pulls 1. So this is basically your cardinal direction. So we're north pulls west, west pulls south, or east, excuse me, east pulls south, south pulls west. So now you'll note I still have 4 other pistons here. So essentially what I've done is I've designed it to have 2 simultaneous motors in a single rotation. So it has a secondary firing order. And what that does is it reduces the mechanical workload. And as we're reducing that mechanical workload, we're also preventing it from having any capability of stopping the rotation. Because in this one, it already can't stop. Once it's fired 1, it's got to fire 3. Once it's fired 3, it's got to fire 5, and so on and so forth. So the orientation of the rotating assembly from northeast southwest would always be in the same direction as it goes around this, but those 8 different lines are creating a circle. If you've ever seen how that geometry works. Now, this firing order, instead of just pulling, what we're going to do with this is we're going to reverse the polarity on our electromagnets, and all that means is instead of having it's not a fancy Star Trek term. It's literally means we're crossing our wires. So instead of attaching our live to our live and our live to our ground, we're attaching our live to our ground and our live to our ground to our live, right? So now instead of the electromagnets pulling, these electromagnets for this firing order are pushing.
It's going to push.
So what that does is as 1 is going up, 5 is pushing down. And then as 3 is going over, we have 7 pushing across into it. So what this again does is it creates a single directional motion that is enforced by 2 different motors that have been completely denied the ability to rest, and it reduces the mechanical workload for them to do so. And once again, there is no friction in this system. So this is going to enable this to work very efficiently in this rotation because it can always maintain that rotation. Now, with this single module that we now have completed, we have 2 free rotating ends, and these free rotating ends are now what we can connect to an alternator. But because we've just designed it as a radial motor, now we can actually stack these. So instead of putting the upper cap on it, we would simply put another crankshaft with a 45-degree rotation, and we'd be able to stack these modules potentially infinitely. And what that does is it ensures that a different piston is firing, assisting in the rotation for the next module that is above it. So this is a standard alternator. I did say I'd bring this up, and this is kind of scary looking to a lot of people, but this is in your car or your motorcycle or whatever you're driving right now. Even if you have an electric car, you probably have an alternator in there. And essentially the point I'm making here is that this entire thing functions by having a rotor, which is these permanent magnets, and they're using regular bearings, and they're rotating it inside of a stator. That stator has 3 different copper coils at 120-degree turns with 6 leads coming off of it, which go into a rectifier to make it your DC or AC power. So now that is how traditional power works, right? So I don't need to reinvent the alternator. I can redesign the alternator, but that is effectively how that works. And all you got to do here is connect an alternator to the north and south, or the top and bottom rotating crankshaft ends, and you will have that power. Now, what that means as far as scientific facts. So as long as the rotation is not overpowered by friction, and again, we have the magnetic repulsion, and our magnets can always be stronger magnets, or our electromagnet could always be weaker so that it does not cause a collision between our magnets. as long as the passing of the permanent magnet through the coil is sufficient to power the electromagnet. Now, again, that is controlled by the strength of the permanent magnet, and it's controlled by the area and the number of turns of the coil. So again, no additional electricity from any outside source is needed to fix that problem. The electromagnet is sufficient to pull the stable magnet without overcoming the rotating assembly's magnetic repulsion. So again, you don't want to knock, you just want enough to pull it towards that direction. And then as it's going through to trigger the next magnet. And again, completely controlled right here. Nothing from the outside has to be added to this system. The force of the rotating body is sufficient to overcome the alternator's winding resistance. And what I mean by that is that this alternator, now, of course, it probably wouldn't be your standard car alternator, although you could use this. As these permanent magnets are rotating inside of this stator, there is what's called a winding resistance, which is basically the electricity being created is giving a little bit of feedback. So as long as you are creating enough force to overcome your alternator, which again is completely controlled by tuning, not by any scientific law that would limit this from happening, then you are creating over unity and you are creating energy without any input of fuel and without any exhaust. And in fact, this entire system can work in a vacuum. It doesn't need to be, it could work underwater. It could work in all environments, in space, et cetera, et cetera. So this is effectively a free energy device once you have built the device. Of course, it is not perfectly free energy because magnets will lose their charge over time. But when we say over time, we're talking about hundreds of thousands of years for magnets to lose their charge naturally from a permanent magnet.
Oh, I didn't know that.
Now,
I have a question, which I mean, just because people will ask, but you just said 1,000, it could take 1,000 years before it would lose his magnetism, right?
Millions
and is there like, you know, disposing? I've never heard anybody talk about disposing magnets, like proper disposal for them or whatnot. If
we would not need to dispose of anything, there'd be no chemical or waste of any type with this product. But essentially what you could do is you could pull that magnet out and run a current through it and re-electrify that permanent magnet and use it again.
Oh.
And that's literally all you would have to do. And you could, you know, save up your 100,000 years of electricity you just made, and you're going to need, you know, maybe a 2-volt battery worth of current to pass through that magnet to recharge it.
I wanted to give a shout out to Toasty, saying a person could also work at a local machine shop and do all the machining for you versus buying a CNC mill or lathe if you're wanting to build one of these, but have no machining experience. So as more and more folks, you know, get interested in this, and you know, they could make these parts for you. That could be a little business in and of itself, right?
Yes, and I hope that kind of thing springs up. Again, I've completely open sourced this. I'm not, you know, I'm not patenting it. It's free to anyone that wants to do it. I encourage you to do it. Please do it. That's the idea of what I'm doing here. I'm not hoarding this. It's not. It doesn't belong to me anymore. I put it out in the universe. It's now yours.
This machine, I guess I call it a machine. Yes.
It's fair, or motor. Yeah.
A motor. Okay. This motor then still needs to be attached to an alternator. Did I understand that correctly or no?
You would use alternators to create the electricity still.
Okay. So the alternator is the avenue where you you connect it to this motor. The motor creates the electricity, or the force to create
rotation.
So the
alternator creates the electricity.
Yeah.
Okay. All right.
Yeah.
And so,
you need to.
Okay.
Yeah. So essentially what I've provided is a way to make things turn. And I know that sounds extremely simple, and that's because it is.
It is, yeah, right.
So now this, because it's a modular design, if you look at this blueprint, I've basically shown that with 45-degree turns of the crank, we have 8 pistons on each module. So if you were to do 8 modules in a stack, you would have a full 360-degree rotation going on. And that means that for each module, you would have a different piston firing in a different position at all times. And that means that an 8 stack is basically the most efficient that you can make this motor. Now, because you've got a top and a bottom alternator, what you can now potentially do is you put your alternator that's on top of this stack, and you use it to assist in firing the electromagnets in the firing order that each one would be firing for its module. So basically, you've supplemented each of those electromagnets in a 360-degree rotation as it fires down. And now, because you are producing energy, sending into that alternator, and that alternator is supplementing, now you can create exponential rotation and force. And you're really only limited at that point by the material sciences, basically the speed of rotation at which this thing would shake itself apart or melt. But that's going to be a very, very aggressive rotation. Now, you can also limit the way that you're supplementing that by using the timing of the crankshaft, which is every time it passes a certain point, that is when you would fire the supplemental charge through this 360-degree rotation of the stack. And that means that now you're effectively creating a high torque scenario on your other alternator that is at the bottom.
I guess I'm lost on the I'm trying to play. Hey, I'm just gonna be transparent. I'm trying to.
No, it's all good. It's okay. And please don't, Melissa. I'm not laughing at you. I'm having my own flashbacks. Like, do it again.
Yeah. I mean,
yeah.
this is recorded, so I love that it's recorded because I can go back and listen to it. But so I'm like listening to it, like I thought it was super cool when you were talking about the magnets and the firing, the different skipping, and one hits 3 and 5 and 7, and like they go in the. I think that's awesome.
Yeah.
If I'm honest, I don't totally understand how that works, but I can comprehend it. But now you're talking about like stacking it. So are you saying making several of these and putting them on top of each other?
Exactly. So
okay.
So that this is designed to be modular. So modular just means basically you can connect many parts, and they're interlocking like a Lego. Mm-hmm. And the top of this crankshaft can be just slightly different for each module, and the bottom of the crankshaft slightly different. So instead of having this long thing sticking out here, you would just have a small.
Make it short.
Exactly. Okay. There's a joke there, but I'm not going to make it. So if your crankshaft is cold, anyways, so you'll be able.
Nobody likes a cold crankshaft. You know what I'm saying?
Yeah. So. So basically,
we're talking physics here and stuff. I'm just saying.
Yeah, exactly. Yeah. So now if you do your stack, you'd be able to use the upper alternator or one of the alternators to supplement the firing of the electromagnets down the stack.
Okay, this is my question. Okay, so this is where I got a little bit lost. So to adjust the firing is the firing of the firing order.
Yep.
That is done as you're building them, right?
No, so your firing order for each module will always be the same. So each of your 8 stacks here will always be the same. But if you're putting a full stack of 8 on top of each other, you're turning the crankshaft by 45 degrees with each addition. And the reason we're doing that is because 8 times 45 is your 360 degrees. So that means that we have a full 360 degree rotation here. And that means that in each of these different modules, one piston is always going to be firing to pull it towards it, and one piston is always pushing it towards the one that's firing. Or
can I just to make sure that I'm understanding you?
Yep.
This is what I heard you say. You make these individual stacks. You make it so they can be stacked on top of each other, and
Yep.
instead of stacking them on top of each other in the exact same position as exactly all the same, you take the second one and turn it a little bit, and then take the third one and turn it a little bit, and turn a little bit, turn a bit, so they're all kind of turned. And so then once it starts firing up, they're all going to be running, but at different times, but continuously.
Yes,
right?
Exactly. Continuously, but everything is pulling in a full 360 degree helical pattern at all times. So now we've reduced the mechanical workload of this system to as near zero as possible.
Oh. Now my other
one
question.
Real quick, 1 second. Question, Hog.
Sorry.
No, it's all good. I'm just teasing you. Can you explain the benefit of reducing mechanical load?
So if you reduce the mechanical workload, then you're able to rotate at a higher RPM. And if you're rotating at a higher RPM, you're able to overcome a greater winding resistance in your alternator.
Okay, cool. Just for those that didn't know that.
Yep.
I didn't know that. Well, my question is on the top, like what you're saying, you have an alternator on the top and an alternator on the bottom.
Yep.
And the alternator on the top you can use to assist. I don't know if I'm using the right language with the firing of the pistons. I don't know what I don't
exactly. So you'd be.
So how does that work? Tell me. So you're using the electricity that's created from this to actually assist the motor itself?
That's correct. So basically I'd be looking at my crankshaft, and by looking at my crankshaft, I'd say that, all right, when this piston over here is fully extended, I want to assist the one that is 90 degrees turned from it additionally, so that by giving it that additional power into the electromagnet, so say piston 1 is being pulled, I want piston 3. Let me go back here a little bit. So piston 1 is being pulled, and I want piston 3 to fire, and it's already going to because this is passing through. But I can measure that my crankshaft has this portion here is rotated so that this one is firing. So I know where it's at. And I'm going to use my alternator above with a crankshaft timing sensor, and I'm going to assist 3 in firing harder or faster than it would be firing on its own. And then I don't actually have to assist any of the other ones in this module. Instead, I'm going to assist the next module that has a 45 degree turn. So I'm going in this same pattern you see here, this rotation of the crankshaft every 45 degrees. So I'd be assisting piston 3 here, and then I'd be assisting piston.
And how do you assist?
Down here.
What do you do to assist?
Basically, I'm just connecting a wire from the alternator up here to piston 3. And then from piston 3, I'd be connecting to piston 5 on the next stack. From piston 5 on this stack, I'd be connecting down to piston 7 on the third stack, and so on and so forth. And then I'm assisting to make that crankshaft turn even faster and harder to create more torque.
He's giving it a little
so bit ridiculous. This is
just giving he's just giving it a little electrical push to make it come out faster.
If anybody
that would increase your speed.
If anyone is watching my face, which I'm sure you're not, but if you are, you probably are seeing me be like, what the hell? I don't understand a lot of this, but I kind of am getting it, which is incredible. just that I even can ask a question that I deem intelligent sounding, but like because this is very curious. This is interesting. This is cool.
So
I cannot even believe that you. Well, yes, I can believe it, but I mean, it's blowing my mind that you thought about doing this and you did it. Like I don't even know what to say. Like you're building something that actually creates power to let it exist itself.
yep.
Yeah.
And you're not using gas and you're not using coal and you're not burning, it's just I'm like, wow, mind blown.
Exactly. And everyone thinks of free energy device. First, it's a dirty word. It says conspiracy theory, and it says breaking the laws of physics and breaking Newton's second law of thermodynamics and all of these things. None of that's true. I haven't broken the laws of physics whatsoever. I've used Faraday's law and I've applied it. And I have used really the most basic materials known to man in terms of producing power: magnets and copper. And that's all we need. We don't need any xenon gas like some people talk about. We don't need tritium. You don't need some sort of fancy element 115. None of that stuff that's all sci-fi. That's all imagination. This is not imagination. This is a very simple, doable, applicable way that physics works, and anybody can build it. And that's what I'm putting out.
Incredible. This
EYI.
person says Adrian's pretty cool walking on thin ice, moving towards Pandora's box. Huh? And it said Kekwoo. I don't know. I first I read it, I thought it was cool, but it's Kekwoo. Adrian Z. Thank you for coming to Dip A Toe show.
So this is the generator, and this is kind of the end of the generator portion of the 4 different technologies. And I know it's been a minute, but so to kind of sum this up, it's very simple. You can build it yourself with a 3D printer, a CNC machine, and some over-the-counter stuff you can order from any hardware. And it's really only limited by the engineering and the material sciences. It is not limited by physics. It's well within the laws of physics and well within accepted science. And there is no legitimate scientist that could deny that this would work, because they would literally be denying the most basic principle of energy creation that we use in everyday technology.
So what is your speculative output per stack at the dimensions that you've shown us this evening?
So assuming you built this using high grade materials, using aluminum 5150, and you use high grade ceramic metallic magnets, and you've cut everything and finely tuned it, and your electromagnets are not going to burn out too quickly and things of that nature. So you've built a high quality build. Then now you're only limited by, again, the material sciences, basically at what RPM is this thing going to shake itself apart, or at what RPM is this thing going to cause enough magnetic repulsion friction to melt itself. And that number should be exceedingly high. And potentially, I haven't tested it yet, but I don't even know that you could melt this thing with any amount of rotation. But there's probably going to be a fire rate or an upper limit somewhere. I haven't found it. But whatever that upper limit is, it's probably well past what it would take for this to be able to produce enough electricity to power, say, a city block. Now, the big caveat to that is there does need to be an appropriate alternator design for this. But if, for example, you were to put this on some sort of gearing mechanism, the Hoover Dam runs just, I think it was 24 or 16, I forget now, but they're hydroelectric generators. And realistically, the Hoover Dam is providing power to all of Las Vegas with just those generators. And you would think it takes all that concrete and all that water and all that, but no, it's really just the turning of those generators.
Right.
And they don't always have them all on because they don't always have load for all of them. So if you were to put some sort of gearing mechanism on this device and scale it to the size of those generators, there's no reason this wouldn't be able to turn the same alternator that those generators are turning. And that means that potentially 16 of these at scale could replace the Hoover Dam and power something the size of Las Vegas.
Holy smokes, man.
That's crazy.
I mean, you couple this type of motor, invention, and like you said, you could mine Bitcoin, for example. And I know the Bitcoin miners and people, they're thinking of all kinds of different ways to harness that energy and use the wasted energy, or like the heat that is produced from mining the Bitcoin, and being able to use that in I don't know what the right word for it is, but I could see this working together with that. I mean, the Bitcoin miners producing heat for heating, pools, or I mean, there's so many options.
And this would make all of the things they're using irrelevant, to be honest.
Yes,
because they don't need any of those things if they build this. They would be able to build these, and because of the income saved from mining, they would be able to build more. And
think about greenhouses in cold climates where you could be mining Bitcoin, producing the heat, using these to power the Bitcoin miners. Now, I know I don't know everything about how this would all work, but that's where my mind goes, is like the possibilities are endless to solve problems that seem unsolvable, but they really are solvable.
Effectively, yes. And as I said, this can be scaled up. It could be scaled up to something the size of the Hoover Dam. It could also be scaled down to something the size of a wristwatch, maybe smaller. Naturally, there's probably a lower limit where we hit quantum physics, but there's going to be micro versions of this made at some point. And if you can increase the alternator output, the winding resistance, and the ability of that micro version, there's a potential you'd be able to power your entire house with one of these the size of a battery, and I'm talking about like a AA battery in an 8 stack, and it would just forever take care of powering your house.
Can I ask you a question as far as so like with electricity at your home, you go messing around with electricity, you could get killed, you know what I mean, because it's so powerful.
There's certainly risks, and build this at your own risk, obviously. As far as the potential for shock, yes, that's there. I would hope that anyone that embarks on this also exercises some safety measures and wears rubber gloves when necessary, and all those types of things. And then also, if you haven't, I would recommend building in an off switch, which you'll notice I did not put an off switch in this design, but you would put it somewhere within a diode within the wiring of each module to ensure you can stop the rotation if you needed to.
Mm-hmm.
Yeah, that's my question, Patrick.
Yep.
So how does this thing begin? Like I didn't even think about that. Like, as you're talking about, you got, how does it even begin?
Yep, because it works off any one piston moving through any piston sleeve. All I would really need to start this thing is to spark any EM magnet enough to pull the piston. And there is no friction or resistance due to the magnetic repulsion. So basically, I could tap this thing with a 9-volt battery and start it, or tap some wires over here, or just put a 9-volt battery with a simple on-off switch, or on switch, I guess, and fire it up.
Wow.
If you want to turn it off, you're going to have to interrupt the signal to the electromagnets, and then inevitably it will come to its own own halt due to the winding resistance.
So you just open the circuit. You just have the light switch that opens the circuit, and it's done. It's off.
Yeah. So you just need a circuit, and that's really all you need.
Sweet.
Very cool. So
get building, America.
I mean, I really wish that I had someone close by that was into this, because I'll just be honest. Like I could probably assemble it if I had all the pieces. I don't know about making this myself, like building the parts myself, but I'm so intrigued. And I like, have you built this yourself? I mean, obviously you probably have built this yourself, so you know it works.
So I have prototyped this, but I will say that that's one of those dangerous areas where if I say that I have this thing running my house, which I don't, but if I said that I did, then that's when I get into trouble with the government, saying that they have some sort of authority to come knock on my door and serve a warrant to confiscate my dangerous device or whatever it is, for violating statutory whatever. But if this is just a concept and an idea, and I'm putting it out there open to the world to play with, to experiment with, to build, and then once there's more than 1,000 people have built this design and proven it works, then we can talk about what I have or haven't built myself as far as these designs and others.
Yeah, I mean, it sure does look as though it would work. I mean, I think I'm speechless.
If anyone can find a reason why this wouldn't work, I am more than happy to have that debate with them.
Yeah. Well, there's 607 people watching Dip A Toe show right now, so we thank you. Please like, share, and subscribe to the Dip A Toe channel. We're at Dip A Toe on Rumble or YouTube, and Dip A Toe show on X. We really appreciate the support. We're trying to grow our channel, and we have interesting shows like Mr. Patrick L. Riley coming on.
This is a very simple. I mean, I'm not trying to belittle it at all, but this is a very simple design. Very simple.
That's and not to toot my own horn too much, but true genius is being able to do something simply.
It has to be easy. Yeah, it has to be easy.
Make a complicated thing simple, and this is very simple, and that's the entire point.
You got Darren Baxter completely intrigued, Patrick.
Yeah. So did y'all have any other questions on the motor, the electric generator, or did you want to move on to the next one? And I do want to back up, because you said at the beginning of the show, though, you said this is proven physics. So I want to reiterate that this is completely proven physics. There is nothing in this design that would not work within the current laws of science.
Right.
Which is awesome. I really if there's anybody out there that's a shop teacher or a homeschooler that has access, I would just love to see somebody take the bull by the horns and build one of these things. And maybe you could have a workshop where people sign up, to try to do it, and start your own little business. I don't know, but I think this is super, super cool. Super cool.
Thank you. So you want to jump into the second one then? All right.
Yeah.
But wait, there's more. You got to do that, Simon. You got to type that up. But wait, there's more.
But wait, ladies and gentlemen, there's more.
Yeah. So the second technology I released is ionic circuits. Now, this is again something that has already been done in the traditional sense. So I did include a QR code there, linking to the plasma channel, which is this video that the still is from, in which he builds an ionic thruster. And, this is something many hobbyists are doing now. It's something MIT put out to basically power a glider a few years back, just in, I think, 2012. So this is a very recent technology to the public. And basically what it is you're taking electricity and you're feeding it into a live, which in this case, what he did is he used fishing wire that or piano wire or guitar strings, something of that nature, as the live. And then he's connecting the ground to these brass plated ones, which are basically air gapped from the live to the ground. And so when you air gap your live and your ground and you leave it wide open like this, what you do is you cause a spark gap. And that means you're jumping electricity from the live to the ground. Now, as the electricity jumps from the live to the ground, it creates thrust. And in this video, he shows, I think, about 4 parts per million or something like that, or meters per second, excuse me, that he's able to achieve just with this very rudimentary, simple design. So this is already being built by hobbyists. It's not something that I just made up or imagined or anything like that. Totally normal, accepted physics. NASA claims to have these in many different satellites now. I think the Cassini used an ionic thruster, things like that. So this is not, again, this is not anything outside of accepted science. Now, I did want to improve on the design. So what I did is, and this would be 3D printed, this plate is for my live, and I'd be coating this in silver, but you would be 3D resin printing this. So just for those who are not familiar with 3D printing, there's a big difference between a PLA or a filament printer and a resin printer. Resin printers are using ultraviolet light to harden a liquid to print this out of a still shape. Those can be purchased for a pretty good one for about $1,000. So they're very affordable compared to most other tooling. And then what I did is I electroplated the same resin print in silver. So that's basically using a sodium hydroxide solution, and you're putting silver leads on both sides of your solution. You're dipping this into the solution, and you're passing a current from the positive to the negative, which causes a buildup of silver on this disc. To preface it, you also want to spray it with graphite so there's something for it to stick to. But essentially, then you're able to create a nanoparticle coating of silver over any kind of odd shape like this one is. Now, this is hexagonal honeycomb, and it has these very sharp barbs coming off of the back, a little bit like a waffle. I tend to call them that. So the waffle and the sharp barbs, the entire point here is that as this is the positive end of my connection, I want these sharp barbs to throw off the positive ions that are pushing that air. And then for my ground, I did a similar hexagonal design, but you've got rounded edges and sharp backs. And this one, instead of electroplating it in silver, silver is the most conductive metal we have in abundance on Earth. Instead of that, I'm using gold to electroplate this one because gold is a very poor conductor. It's about, I'd say about 56% as conductive as silver, and much less so than copper. Now this chart over here does say aluminum is just below gold. For the record, aluminum is very low conductivity, so that should give you an idea, and everything below that is much lower. So those are our options, and I went with silver and gold. So I'm going from the most conductive to the least conductive because I don't want those positive ions to be able to take hold as they hit this ground. I want them to keep traveling. But now this is the magic part of this. This is the circuit. So what I've done here is I've taken 2 positive plates and 2 ground plates. So it starts with 2 positive, it ends with 2 ground. And I am shooting, my connection is going from the first plate to the third. But as those positive ions travel from 1 to 3, 2 is picking them up because it wants to shoot them to 5. As it's doing that, 4 is picking up because it wants to shoot them to 7. So once again, I've denied the positive ions that are moving through this hexagonal fractal design any ability to rest until they get to the end of the design. And each of these pairings is independently powered as a live and a ground.
Okay.
Now I can then wrap that circuit of waffles in a permanent magnet. And I'm wrapping it in a permanent magnet because I'm creating magnetic pressure against the ions. So if you're not a science person, ions, positive ions, electrons, and light all react to magnetism. So I'm using the magnetism to create pressure to force the traveling ions towards the center of my stack. And then I've also wrapped this in a coil, and I'm sending a current through that coil to create a rotation or a helical pattern within that fractal design. So now I've excited all of my positive ions that I'm pushing to the back, and I'm going to condense them into a high pressure ionization chamber with my nozzle design here. It's just rocket science. It's not that complicated, I promise. They did it in the 30s. So they're basically, all of those ions are getting compressed right here, and it has a very narrow way to exit, and that's the ability to create thrust. So now I have, instead of a very weak, 4 meters per second type of thrust, I'm able to create, again, a scalable amount of thrust that is actually limited not by the design, but by the amount of electricity I am capable of putting through it. So this design has the ability to replace things like jets in airliners and replace them with an electric drive. We have the ability to use this in space travel, and ionic drive does and is proven in space. And this can again be used for infinite other applications. So because I have my generator or my motor that is able to produce an exponential amount of electricity limited only by its material design, pairing that with this design gives me the ability to create basically an electric rocket, so we can stop wasting fuel in Elon's rockets. So any thoughts or questions on this portion or this? It's actually very basic, very simple. Like I said, it's just rocket science.
Yeah. Well, for my basic general understanding, that's pretty straightforward. It really makes sense, especially here at the high pressure ionization. You're basically you're using physics that already exist. Garden hose through spray nozzle. You're reducing the path of travel, thus creating, in that instance, pressure or force. Right. Yeah. Thrust. Yeah. And you're same thing here. I think that's what's great. No new inventions per se, or no new physics, just the same old stuff that we've had forever applied differently or applied just in a different type of system.
Yeah. And really the only innovation in this that I could claim as mine is the circuit itself. This is what I'm doing that no one else has done.
Right, your firing order. Well, not really your firing order. That's
I've denied. Yes. Yeah, I've denied rest, and I've amplified, and that is kind of the ingenious, I guess I would say, of this specific innovation.
That's cool. That's really cool.
You still with us, Melissa?
I'm here.
Right on.
Yeah.
That's really cool. So,
Something else.
that's never mind. No, I'm gonna ask that later. Different show. I'm gonna let this marinate before I go down some roads.
All right.
No, that's. But wait, there's more.
Yep. So, Melissa, did you have any questions before I move into this one?
The only question that came to my mind, but I missed the end of it because I had to step away for a second. But what would you use that invention for? Like how would you incorporate that into?
So you could use that to replace jets in, say, passenger airliners, to replace jet engines. It is going to create thrust and thrust sufficient to propel a plane through the sky.
Wow.
On that note, just thinking fantasy land for myself. The thrust itself, does it create? It would not create any heat, correct?
It would create heat. It would
create heat.
It would be very hot. Yes.
Damn. There goes my Iron Man suit. Never mind.
Well, you just gotta have the right heat shields.
Yeah, I gotta have the right heat shield. I know. I was just like, wait a minute, can we jetpack this thing? But no, that's okay. we'll work at it.
Yeah. So, all right.
We are on the third technology.
Yep. So now this one, as you stated at the beginning of the show, is conceptual. So all of these concepts have already been proven. This is, again, just a different way of applying the concepts. It's not so much a matter of physics. It's quantum physics in this instance. However, I will say that I was in communication with a gentleman that worked for the SSP. That's not the secret space program per se. That's the strategic systems program of the Navy, who had a problem to solve. And I communicated with him about specifically this technology, and the problem was solved. I don't know any more than that as far as if this is actively in use today, or if they moved another direction. I don't know. We were communicating through email, and we didn't keep in touch. But so this is a fully conceptual technology. Now it's called a quantum helisphere, and the reason it's called Hela is because of this lady who is probably the future of computing and the future of medicine and the future of quantum technology and quantum blockchains. And she died in 1951. Mm-hmm. Now, Henrietta Lacks died of cervical cancer. And back in 1951, it was standard practice for medical research to take some of those cells from a cancer patient and study them. Her cells specifically are known as the Hela line because her cells have a mutation in the cancer in which they are basically immortal, because the telomeres on her DNA are extended and do not die. So basically that single cancer cell, they're still alive today, and they're still being used in all kinds of medical research all over the world. And this is a very well-documented thing that's out there, and most people just never heard of. But she is the mother of modern science in many ways when it comes to quantum, because very literally this is of her body. Now, what is quantum entanglement? Yeah. So, quantum entanglement, this is a proven, scientifically demonstrated thing that we already know and have done in science. This is a article on Atlas about quantum entanglement accomplished inside of CERN, but if you don't trust CERN, go Google quantum entanglement. It's been done many other labs as well. And essentially what you're doing is you're interlocking two like bodies that came from a similar source, and they move in tandem simultaneously at any infinite distance across time and space. And they do this completely devoid of light speed. So this is instantaneous. So whether it was 10 feet away or 10 billion light years away, if I move one, the other is moving exactly equal and opposite to the one that I moved. So that is quantum entanglement.
That's interesting.
Yep. Now, the reason we want the helicells or the helisphere is that because it is a human biological cell, we are able to grow it through generations, and it is already through mitosis. It's a clone of one another, but we're also able to grow it to a larger size. In the same way that if you take a shark and you put that shark in a little fish tank, it's not going to grow any bigger than the fish tank.
Right.
But in the ocean, it gets very large. So with the helisphere or the helicells, if we breed them through generations, the cancer cells will get larger if they are provided the right atmosphere and the right nutrition, essentially, to reproduce to a larger size. But they will still be a clone, and they will still be immortal. Now, with that, we would want to grow it to essentially the size of a golf ball. And at the size of a golf ball, we are able to inject iron into that cell, that orb, because it is already naturally within our bodies. We have iron in our bodies. So we've injected Fe and we've created a grid. Now, the grid design that I used is a 2,800 mil circumference, and every intersection of those 2,800 mils, which comes to 32,000 data points within a sphere.
Okay.
Now, as we take those spheres that are now injected with the ferrous material and have a grid on them, we can basically immerse them in superfluid helium, that is He2, that has been brought down to 2.17 Kelvin. And what superfluidity means is that helium will pass through solid objects. It passes through the space between the atoms within those objects. So if you tried to put superfluid helium in, in a hard container, it will go right through that container, with the exception of a few different materials, stainless steel being the preferred container for superfluid helium. Now, as we brought it down to 2.17 Kelvin, which is basically near zero freezing temperature, we are now able to use frequency and vibration and sound waves, essentially, on those cells. And we're going to walk that frequency from a very low frequency, and we're going to walk it up until we have a perfect quantum entanglement. We don't know exactly where that is going to be. It depends on the wavelength of the cells and things of that nature. But we would walk it up until we've entangled them, and we have that relationship of a equal and opposite reaction across time and space. Now, the way that we would do this is basically, this is a mock-up of an apparatus in which you would be suspending that quantum helisphere using magnets, and you would have a north pole and a south pole that are already designated. So every rotation within those 32,000 bits of data is going to give you a rotation in the other cell within those 32,000 bits of data. So that means that simply by rotating this 45 degrees or 90 degrees, I can send 900 different bits of data. And all I've done is slightly rotate it. So I'm able to send mass amounts of data across time and space instantaneously without the need for accommodation of light speed.
I'm really, this one's got me confused.
So this one is probably the most complicated of all of them, as far as understanding at a normal person level, because normal people generally don't have much of a background in quantum science and entanglement and helispheres and that type of thing. But all of these are proven concepts. that have already been done. It's just a mixture of them together, and more specifically using the biological cell for a body to quantum entangle for a computer. But what that essentially means is that now whatever data I pick up at this one, if this is on Mars or if this is on Pluto or if this is many light years away, I can take data from a regular computer interface, program that or code that into some form of rotation on this one that we have already predetermined back on Earth, that rotation means this, and I can send live data across time and space. So
and you're using it uses, so this is where I'm confused. It's using cells?
Yes, it is using human cancer cells.
Using human cancer cells to transmit data.
Yes.
Yeah.
Am I getting that?
That's correct.
So why does it have to be a cancer cell?
So specifically because to quantum entangle any object, you want that object to come from a like source. So you can't just quantum entangle right now, at least to our knowledge. We don't know how to quantum entangle, say, a banana to an apple. But if we had a single apple that somehow split into two apples and they're an exact clone of one another, we could very easily quantum entangle those two apples. So because of cell mitosis and because it's a cancer cell and it literally is made to grow and spread like cancer, pardon any insensitivity to Henrietta Lacks in that, that makes it an ideal candidate for this type of application. And it's also immortal, which means that we don't have to worry about that cell degrading even in a harsh environment like space.
Wow. I don't even know. I'm like, I mean, there's a lot of,
Well, let's take it back, Melissa. Let me break it down for you just a little bit more. You know that you are your bio, right? You got cells in you, right? And you're firing off little electrons up in your brain, right? Correct? Yes, no?
Yes. Oh, yeah.
Yes, that's how it happens, right? Okay.
Yes.
So basically, what is being explained is we need the cell because the cell does all the cool stuff that we want it to do naturally. We have different cells that do different things in our bodies, but nonetheless, they do different things. Arguably programmable. I'm not going to get into that, okay? But you can give it data. You can give a cell data, and the cell can produce data. Would you agree with that?
Yes.
Okay. So the cancer cell, specifically this one, the Superman of the cancer world, right? Can live forever. Has the ability to do the things that Patrick wants it to do as far as the data, the erosion over time. So now we have something that's going to be around forever in all types of conditions that are known. So it's going to last. Unlike us humans, you stick me out in 120-degree sunshine, I am done for, right? Or the opposite end of that, extreme cold. Nope. Simon Says Crypto is gone. Goodbye. But a superhuman cancer cell here is going to be around for quite some time. And also, it can pass through space and time, which there's not many things that can do that. In regards to the data, it has the ability to do that because of the quantum entanglement. Brain cell over here, brain cell over there, different brain cells, arguably, but very close to the same in my brain and my body. All blood cells, all working together. It's just expanded from Earth to Mars. Does that make sense?
Kinda. I don't know.
Okay, kind of not. Cool. Cool. I lost you at Mars, didn't I?
So just to kind of sum that up, or the easy way to sum that up is this is really, if you forget that you're using a biological cell and you forget that you're even quantum entangled, what this does is it allows us to send information quickly and effectively across time and space without the need for wires or line of sight or light speed or any of those things. It's just instantaneous, and that's it.
So, string theory, does that play here?
It not really.
No.
String theory is more of a multiversal type of application.
Okay.
I mean, it's always plays somehow, but yeah, it's not really a direct tie-in.
And not a direct. Okay.
Yeah.
Okay.
So essentially this is to communicate. So now we have our motor, we're producing electricity, we're producing thrust.
Mm-hmm.
Our thrust can also be, relatively exponential given the material limits, and we have the ability to communicate. So the last thing we need is faster than light travel. Now, faster than light travel is one of those funny things where people think that there is a light speed limit, and we really already know that's not true because we have examples of things leaving from a coronal mass ejection of a black hole, and we have things like quantum entanglement, and we have the Alcubierre drive formula proven in 1992 that we can go faster than light, but people still think this is a thing that's going to limit us. So I've still have a mitigating technology that can take care of that. Now, I'll preface that by saying humanity to date has only admitted to going up to 400,000 miles per hour in a probe, space probe, as the fastest moving object made by man. That is 0.005% of the speed of light. So the idea that we can't go faster than the speed of light is a little bit ridiculous. And it's just as ridiculous as in the early 1900s when Time magazine said that a car would never go faster than 100 miles per hour because it would run into the wall of air in front of it. They also said we could not fly because it was impossible, and no one knows how airplanes work. It's just magic.
Yeah.
So that is basically what faster than light and the light speed limit is right now. Is it's a silly misnomer that Rupert Sheldrake disproved, and actually proved that the speed of light has changed over time. It's in flux, which means that they have no idea, and science is lying to you. Anyone telling you there's a light speed limit, they're lying to you. They have no idea. And we have proof to the contrary. And it doesn't take 100 proofs, it only takes one. In science, that is how the scientific method works. And scientists these days don't like to actually use the scientific method, if anyone hasn't noticed. So now, faster than light travel, of course, I had to give a shout out to predecessor here, Nikola Tesla. If you wish to understand the universe, think of energy, frequency, and vibration. Everything is in those terms. But this is a very simple way to beat light speed. So what I've done here is essentially I've created a torch, and by that I mean a flashlight, but it's not just an ordinary flashlight. It's using ultraviolet C or UVC light, which is the heaviest proton. So you can actually, and I have one here, actually, I think. Let me see. Yeah, I do. I forgot I'm in my office. I have this available right now. So I have an ultraviolet flashlight here, and this UV light is able to move atoms of heavier material. So if I take this tinfoil bag that you can't see through it or anything like that, right?
Yeah.
Mm-hmm.
Would you think that if I shine a light inside this bag, it's going to go through the bag?
Say no, Melissa.
Yeah, no.
Oh.
The light. So I'm moving, quite literally, the light, the heavy photons are shining right through the bag because they're moving the atoms at the atomic level out of the way. So now if you're able to produce enough electricity behind an ultraviolet C torch or flashlight, and you're able to create a wall of ultraviolet C light that is coming from your device in front of you, you're able to create basically a hammer or a blunt force object that is going to use light speed at light speed to move anything in front of it out of the way.
Okay, so can we go through the wall? Can we go through the wall? Like, that's what you're presenting, right?
Yes, you can. So now if you go back to the screen here, so now
I got you.
Come on.
So there's two different methods here. So there's the blunt force method, which is basically I would create a cone of ultraviolet C radiation and I'd push anything in front of it out of the way.
Out of the way.
Right? Now the other method is I'm working at the atomic level with these photons interacting with the atoms of any solid object in front of it. So instead, I can use frequency and vibration, which is why this thing looks like a subwoofer. It's because it is. I can use that frequency and vibration to align into a grid the atoms that are in front of the moving object. Now, if I align all of the atoms in, say, my hand into a grid, and I know exactly where all of those atoms are, you wouldn't be able to tell looking at my hand. And I align the atoms in my other hand into a grid, but I make them slightly off. I've changed the frequency, literally the frequency of the subwoofer of what's inside my object and what's in front of my object, and I've misaligned them. So none of them can ever touch, and it just passes right through. And that is exactly as you said, you would be able to move a solid object through a solid object because you have overcome entropy. Entropy being basically the diffusion of those atoms into a random orbit or a chaotic orbit, usually not completely chaotic, it's more of a fractal, but something is touching. And there's actually way more space between our atoms and our electrons than there is atoms and electrons. It's just that they're all able to make contact with each other. If we align them in two different grids, they won't. It's just going to pass right through.
Yeah.
So now with that, if I've either chosen to make a cone out of light, traveling at light speed in front of me that is pushing everything out of the way that may come in front of it, or I have made everything in front of me on a different frequency, now I have no resistance or no potential resistance in front of me. So I don't have the ability to run into any minor object, I would say. I wouldn't encourage people to shoot this thing into a planet or a meteorite or anything of that nature. I mean, for science, I'm sure we'll do it, right? But if you're just traveling through what's mostly empty space, and your speed limit is essentially light, allegedly, then this overcomes that obstacle because there is no light in front of my moving object that I have to overcome because I've used light to move it out of the way. Now, if you subscribe to Einstein's theory of relativity, now I will say Einstein was a fraud. He stole most of his designs and ideas, et cetera, et cetera. But if you subscribe to the idea of relativity, then as I'm moving faster than zero and I'm shooting something out at light speed, I am already moving the light from my moving object faster than light speed.
Okay.
So that means that the entire concept of light speed is really nonsensical. People love to tout scientific facts as if they are facts, but there isn't really any such thing as a scientific fact. There is a scientific understanding, and our understanding as a species is about 200 years old. It's very infantile, if you will. Pretty much everything that we're working with right now as facts is wrong, and we don't understand what we're talking about. So that you should always assume you know nothing. And then you're able to actually create based on what what you can think of. So now that gives us our fourth technology. So we're able to remove the resistance of space, and we're able to overcome space-time communication. We're able to overcome the energy need, and we're able to create thrust at an exponential rate. So that's our 4 technologies that I revealed, and that's all great. And there's
more.
There is more. So there's infinite uses for these, but I did want to highlight 2 potential use cases for these, because that's really the motive behind the design for me, or the motive behind releasing these 4 technologies together, I should say. So by combining the 4 technologies, I now have my hyperspeed torch here, if you will, called the Thoth rocket, which is the history of temporal humanity. It's called that for a reason. I'm using light to push things out of the way. You may notice my ionic circuit is also on the exterior of the rocket, because that is also going to aid in thrust, but it will also remove crosswind contamination even in space. So I'm using plasma down the length of the rocket to basically remove any resistance that may be hitting the side of the rocket if there was any kind of cross current. And then I've got my thrust. So use case 1 for Thoth. If we put a giant mirror 10 light years away from the Earth and looked at it through a telescope, theoretically we'd see 20 years into the past. So this is just a common meme that floats around, and it's a common science trope, but it is accurate in concept. So right now humanity has not admitted to faster than light travel publicly, or having gone faster than light. But if we are able to go 10 light years away, and we're able to communicate instantaneously back to the Earth using the quantum helisphere, then anything we would be able to see with our satellite is 10 light years old. We would be able to gather the history of the Earth, and we would be able to do this by sending tens, hundreds, thousands of these Thoth rockets, and we would be able to effectively record the visual history in a 4-dimensional Google Maps format of our past, of humanity. So that means we would very literally be able to watch the fall of Atlantis. We would be able to watch Jesus Christ live his life, whatever life he lived. We'd be able to watch them build the pyramids and find exactly how it was done. We'd be able to track who really shot Kennedy and the path of the magic bullet. We'd be able to view the dinosaurs, or even the forming of the Earth in its infancy and the moon. Now, all of these things become possible because we are traveling not only faster than light and communicating instantaneously back to Earth, but we can also send these probes in the direction that the Earth has traveled through the solar system. The solar system has traveled through the galaxy, and the galaxy has traveled through the universe. So we are going where the light is the most concentrated, and we are collecting that light similar to how we do with any other keyhole satellite or the Hubble Space Telescope or anything of that nature. And because light is a particle or a wave, even if we send our rocket right through that light and stop, we are still going to receive the same image in the same picture, and it is scientifically reproducible. It can be sent on that quantum helisphere back to Earth, and it can also be encoded into a blockchain in that process to record the true history, the actual history of temporal humanity. So we can know exactly what happened. That also means that what's done in the dark is brought to the light, and that the future proves the past. It means that we can find every missing person, that we can see where they went. We can solve unsolved murders, and we can stop corruption as it happened.
Wow. Wow.
So So that's one application of these four technologies combined.
That's just one. Yeah, you could just use that for that. I mean,
yeah, it would completely change.
No big what, no big whoop. Just one of the use cases.
I don't see Patrick. I don't see what all your fuss is about having the dead man switch and all that. Like I'm just not seeing a reason, a logical, ethical reason.
Totally unnecessary. Yeah.
Hey, but what the heck? You want to build a dead man switch? Build a dead man switch.
I have a question. So I'm like, is it possible that they have already built something like this and that they've been using that's all along, right? Like this is how they are.
But yes.
Okay.
And so that's kind of where this next use case comes in. But essentially, what you have to understand is that time is not linear. And we do know this. We've proven in labs that there is such thing as time mirrors. You can actually reverse time. There's time crystals, things of that nature that prove that time is not linear. Everything that has happened, is happening, and will happen is a solid. The only thing that is any kind of time at all is our experience or our perception of the motion of events. So with that said, that means that everything that has happened, is happening, will happen, is a constant. And because of that principle, that means that we would be able to put some sort of device on Melissa's head. It's going to look a little bit like a hairdryer.
Gonna put it on my head?
Yeah,
your turn.
We're going to put it on your head, and we're going to read or do a brain scan that determines what are the physical, biological structures of Melissa's brain that are present now, which would have been most alike or most present in Melissa's head 10, 20 years ago. And then as we are viewing you 10 to 20 years ago through the Thoth rocket, we're viewing you in real time in the past. And we can say, well, here's the temperature, here's the resonant frequency, here's the structure. And we can use the device today to basically quantum entangle your mind today to your mind 10 to 20 years in the past.
Holy shit.
So we don't necessarily know what that experience would be like. We don't know if you would have full knowledge or if it would be something like a deja vu, something like a passing intuition or a passing thought or something like a submersive thought. But you would be able to communicate with your own mind in the past from the present. So that literally means that humanity moves from the third dimension, which we live in currently, into the fourth dimension, in which we are no longer bound by time and space. We are now a four-dimensional species outside of time. And we can be a truly ascended species if we focus on ascension. So that means exactly.
Yeah, man. Yeah. I'm gonna be up tonight.
And so you asked, has this ever been done? So the story I told before is, my son. It was December 4th, 2017, and he was born in June 2012. So he would have been 4.5. At the time, he kept writing out a mathematical formula. He would write it in crayon on his drawings, and he would write it on the fridge using magnets, and he would write it all over the place, and we didn't know why. And that was fine, but eventually we decided, hey, let's Google this and see what this formula is. Only one result came up for Googling this, and it was this book from 1981 that is specifically Adaptive Mesh Refinement for Time Domain Numerical Electromagnets. Now,
wow.
We asked him, when do you want this book? And he said in the most adult voice we'd ever heard, when I'm 16.
Wow.
So I don't know why, I don't know how, but does that suggest to me the possibility that this technology has been built and succeeded in the future? and somebody in the future is communicating with somebody now.
So that's where I was going to go with it. As I said, got all excited.
So the answer is yes. And that does raise the question, you know, there are Riddlers, there are things like Q, there are things like Mr. Poole, and there are people that believe that those people are receiving messages from the future or messages that are somehow being communicated. And I'm not saying that's what's happening or that I know that to be true. I'm not saying I believe all these entities that are out there telling these things. I'm sure some are more credible than others. However, if these people were sending a message from the future to the past, this technology that I've just revealed and we just talked about is what would enable that to happen.
Yeah, man.
I mean,
that one you got me on the.
So there's my 4 technologies I've revealed. And yeah, so it's pretty simple.
Crazy.
yeah, it's really easy.
Yes.
It sounds it's no big whoop. I mean, it's hard to even
No
wrap
big
my
whoop.
mind around it. Like I get it, but I don't get it, right? Like the possibility of that. You know, the whole communicating,
That
the
makes sense.
cell transmitting information.
Already happens. Already happening.
Yeah, it's just
Smack your hand.
So none of the, and that's the important thing I really want to communicate here is, you know, people that follow me probably don't have a lot of conflict with this, but people that have never heard me speak before, they're going to have some trouble understanding this. So I just want to reiterate, the over unity generator is within the proven laws of physics. It will work. The ionic drive circuit is within proven laws of physics and already built prototypes. It will work. The quantum helisphere is within proven concepts, proven laws of physics, quantum physics. It will work. The faster than light travel or faster than light torch, if you will, is still completely theoretical. And it's only theoretical because no one has ever tried it. But I am confident it will work. So now with those 4 technologies combined, that I am quite confident will work, and I'm confident enough to go out and speak on it and to do this show and to put the designs out there and to put my name on it.
Yeah.
Right.
With those 4 technologies, we can do a 4-dimensional Google Earth map. And with those 4 technologies, we can quantum entangle to the past. And we know all of these things scientifically. And nothing that I presented here is outside of the well-accepted scientific bounds of physics that we know today, with the exception of faster than light travel. But I'd caveat that by saying that the Alcubierre drive already proves mathematically we can do that, as does coronal mass ejection from black holes.
Mm-hmm.
wow. So what do you so do you think that they really have, I mean, governments, I'm sure, have been, you know, trying all different kinds of things under lock and key, like nobody knows about it and whatnot.
I would say that our publicly acknowledged technology at this point is probably about 100 years behind of what the government privately has. And people need to understand that technological development is exponential. And I do have knowledge of different entities within the government. I used to, you know, be a part of the government, as some people know. If you don't, I was military for 16 and a half years, and PSYOPs, civil affairs, and special ops, and that type of thing. So I'm well aware of things that are out there that are more advanced than even what I'm releasing. But more importantly, this isn't a leak. This isn't a stolen technology. This isn't copied technology. This is all my own invention, and I am simply putting it out for everyone to have it.
I mean, which is it's gutsy. I mean, it's gutsy for sure. I would just say we have 683 people watching Dip A Toe. Thank you for coming to the show and watching and staying in for this interesting conversation. And if you're intrigued and you want to look up these inventions for yourself, how do they find those, Patrick?
Yep. So I'm on Twitter and my handle is at PLR_2024. And I do have the post about these inventions and the NFTs that share the diagrams for them is pinned to the top of my profile. So it is the first post you'll see, as well as if you scroll down in that same post, you'll be able to view my presentation at the Quantum Summit, which is only about a 30-minute presentation that goes over these technologies. Or, of course, you can always rewatch this episode. Yeah. And if you're listening, I do ask you to do Simon and Melissa a favor and hit that like button.
Yeah, give us a like.
Subscribe. Yeah, thanks, they need those subscribers on YouTube. Help them out. Help that algorithm. If you help them with the algorithm, you help me with getting the word out and getting people building these prototypes. And the more people that build these prototypes, the sooner we can remove dependency on big oil, remove dependency on fossil fuels, remove dependency on energy companies, remove your electric bill. Stop polluting. If you actually care about climate change, if that's a thing, then you should 100% be behind me. I'm not a leftist, but for those who care about that, yes, this does fix that too. So please go ahead and like and share and subscribe.
Thank you. You brought up a really good point that I've been thinking about with all of this stuff. And as I'm expanding my thinking and I'm asking questions and I'm meeting so many different people and I'm talking about subjects that I would have never thought about before. The whole climate change and just certain topics that they like to kind of pit us against each other. This. If you say that you don't agree that climate change is real for this or that reason, then people attack you, or vice versa. I mean, it it really doesn't matter. They want you to be divided over these. I'm sorry. I get it.
I'll just say, as far as climate change goes, I'll just throw in there that about 80% of the precious minerals that are used in the development of both wind and solar come directly from China. And I'm not saying that humans aren't contributing to climate change. Of course, we contribute something. We are doing something. Sure. I'm not saying one way or the other. I don't really honestly care, because I have solutions that make it a moot point for me. But as far as the climate change agenda goes, and why I would talk against that, is because those precious materials coming from China are being purchased by the United States for billions and trillions of dollars, which China turns around and invests in our politicians to get them to promote climate change. And that's just a circle of money washing between hands, and it's not necessary.
Sorry about that. I was like, I had like a tickle in my throat that's just started, and I might even start coughing again. But what I was trying to say is that certain things, like, we all want a cleaner planet. If we can produce energy in a cleaner way, if we want to stop wasting and like destroying our, putting garbage and waste and nastiness and stuff, we want clean water. We want all that. Like, we all want that, right? And so that's what's so encouraging about this space and all of the new technologies and ideas like yours. It's moving towards that direction where we don't have to produce such dirty energy as what we're dependent on now. And once you realize that the powers that be have held back these technologies for so long, so that they could make money, and what they do is they manipulate us to fight against one another. Well, they're the ones that are the perpetrators of it all, right? And
Yeah.
so it's awesome for us to come together and support things like this and really ask the questions and think about it logically. What's really going on here. So
Yeah, and I would just throw out, and this is going to sound a little bit ambitious in an entirely different direction, but I alluded to it earlier, that one of my fascinations is in consciousness and universal consciousness. And in that sense, the universe, consciousness, and God are all one and the same thing. And money is God, and God is money. And I'll explain that a little because it's an inflammatory statement. So when you take your work, or you take your labor, or you take your possessions, or you take natural resources, and you monetize them, you are taking a portion of what is God, because God is everything, and everything that is a portion of God. So you are taking a portion of that and you are sending it somewhere, or you are centralizing it. And the more money that groups have, the more money that any person has, the more power they have. Money is power. Power is the ability to do. And God is all powerful. So essentially, by hoarding money, they are taking power from God. They are absorbing a portion of God into their own will and taking that control over that portion of the universe by taking that money. So by taking something like this idea and festering this idea out into the universe that decentralizes and removes their ability to sop up money into big oil or into utility companies, or to wash China's back with renewable energies, you are taking back power quite literally. And you are also getting closer to God as you do that, because you are taking your control back from them. You're taking the power back from them. And so that's all a roundabout way of saying that by doing this good thing for yourself, by building this technology, you are serving the universe, yourself, and God, and everybody else in doing so.
Yeah, you're fighting the man.
Actually,
taking away the
you're not
power
even-
from the man.
You're not even fighting. You're not fighting anybody. That's the beautiful part. You're
Well,
removing yourself.
They'll
You're removing yourself
look.
from the equation.
Yeah, they'll look at it as a fighting back.
Sounds
I
like
mean,
personal problem.
Everything
Why
that
it's
we do.
decentralized.
Yeah. Which I mean, I think this is great. And there's so much potential here.
A lot.
I mean, a lot of potential. I really hope that people build this, and we start seeing people comment on building these things and trying them out. Even just starting off building one small little motor to create their own energy to power a computer or whatever, anything, or like a mobile unit to go camping with or something where you I don't know, so,
And I promise, when you do one of these and you see it working, it's going to be one of the best feelings of your life when something you built does something like this. And the satisfaction, of course, for me, it's maybe a little bit different, but I think anybody that builds this would have a similar satisfaction.
Oh, heck yeah. I mean, this is silly, but when I was a little kid, there was a science fair, and I mean, it's not I had a doll house, and I wired my doll house
with a battery, right? And made all the little bulbs and things throughout the dollhouse. I lit it all up, and I mean, I know that's like really simple, but to me as a little kid, I thought I was so cool that I made this, you know. In my mind, I created electricity, but I mean, I could imagine as an adult building this and powering something, I would feel like such a badass. You know what I mean? If I could actually do it. And you know, really the kind of person that I am, I could do it if I put my mind to it. I really feel as though I could do it. But I'd have to teach myself how to use all of the machinery and all of that. And that's where it'd be much easier to do it with a mate, or two. You know, in troubleshooting it and all of that. So what I'd love to see is like people forming little groups, collective groups, and you know, they're all building it and being able to talk to each other and say, I got this far and I got that far. Like once we get to that point where people are starting to build these things and started networking amongst themselves, and you know.
Exactly, and that's what we need is a network of builders assisting and helping other people to build it, and benefiting from it themselves and telling their story.
Yeah. Wow. What you say, Simon? Well, I gotta say, wow.
If you build it, they will come.
Hell yeah.
No, it's great. It's a great design. All of it. I like it. In my mind, it makes sense. A lot of good sense. So you explained it very, very well. Kept it as simple as possible, without going into the super details, which I think is key. As we mentioned before, it has to be simple. You know, the first technology you shared with us, man. That's I could, you know, I definitely see people here probably even after this bull run going, you know what, I'm gonna do that. At least for the next 3 years, I'm gonna try to do that. You know, it'll just be something to do, and there'll be a few that succeed, and that'll inspire more that might have hit walls. And then you know, however the light that's really cool, and I instantly thought of the movie Event Horizon. Have you seen that?
I have seen it. I believe that one was a horror, though, right?
Yes, it was. Yes, it was. But that's immediately what I just thought of. I'm like, oh, it pushes it out of the way, and now we can go through a wall. And wow, that's amazing.
I was actually I was joking the other night with someone that if I make movies at any point, I'm gonna make a space movie where they go out in space, they go do their thing, get to Mars or whatever, and they come back and absolutely nothing extraordinary happens. It's just like a sitcom. Because how are they getting at those points? There's always like somebody getting spaced and always some collision, and it's always so dramatic. I'm like, no, it's probably way more boring than that.
More boring.
Right. Yeah.
Yeah.
Most definitely is. It's not sensationalized. What are we
Well, you
looking at?
got a
Potentials?
juicy little screen up there now, Patrick.
Yeah, so he said the next bull run, and I know we put it in the title, at least for the Twitter, that we talk about XRP. And so this is the chart that I have for XRP. And if you think that I'm a moderately intelligent guy, I like to think that I am. This is the way that I chart it. And I've got my my 2013 to 2017 flag here, which was an A movement, a B movement, and a C movement, which travels across. And then we had our parabolic run to the last all-time high. And we had an A movement, a B movement, and a C movement, which travels across, and we are sitting above right now. And at the same time as we're sitting above that, and I hadn't adjusted this chart since, let's see, it was 19 February 24. So I haven't adjusted this since February, but we're right where we're supposed to be. we dipped below just as we did in 2017, below the end of the triangle, and we moved above it. This is a weekly chart, and after the end of this week, there's only 2 to 3 weeks left in this triangle. And if we're able to maintain and sustain and get above, it looks like 68 cents next week. So we really only need a very small movement and maintain above that. And then we are in our next bull run for XRP. And I think that's a very high potential. Now, I do this in bars. So you'll see these slightly diagonal bar lines here. That's the average upper to the lower trend line, and moving to the lower trend line of the next flag, and then carrying that same distance up. And this is on a logarithmic scale, and then carrying it up in addition, right? So if we take the distance between our previous flag closing to our previous all-time high, and apply that to the same end of our current flag, we would be at a price point of about $290 potential. So I'm not saying that's going to happen, but I think that at least a minimum of half of that is very likely, and that's where I got my $22 prediction for XRP within this year. So I do still support that prediction. I do think that we could see it in the very near future at this point. I think we could also see the end of the case in the very near future, as well as FedNow launch with XRP compatibility. We're going to see the RLUSD stablecoin. We're going to see ETFs for XRP. We're going to see Japan swapping into XRP rather quickly, as they can only do so much compensation for their currency in Forex. And we also just saw Russia announce today that Putin signed into law a CBDC, and he was complaining about mining being 1.5% of the nation's energy expenditure. So unless he wants to build a whole lot of my motors, I imagine he's going for a blockchain that doesn't have mining and energy expenditure. And that suggests to me it's probably XRP, which makes the most sense. So I think we have a lot of bullishness in front of us. How y'all?
I have a question. Of course.
Of course.
All right. So you went over your ABC, and then you got to where you're going to the next. How when you went up to the 290, and then you were like, I'm still seeing 22. It kind of like jumped to that. So I didn't know where you had predicted or gave your opinion on the $22 mark. But how does it get to the 290, and why? Why are you thinking?
Yeah. So as XRP does move, currently, if you go and calculate the market cap, between $15 to $20 for XRP means that we are going to be the number one cryptocurrency in all of them. We'll surpass Bitcoin as the number one cryptocurrency. With that, having regulatory clarity that XRP is not a security, and having the end of this case, along with Ripple having integration into banks worldwide, ETFs and all of those things, institutional money could actually come into XRP. And with that, we also, right now, there's only about 5 million wallets out there. The 5 million wallets suggest an average of 4 to 5 wallets per individual. And of those 4 to 5 wallets per individual, so we're down to 1 million wallets, at least 20% of those wallets are the top holders that are institutional already of some sort. So there's only about 800,000 people in retail holding XRP, is what that means. So 800,000 people out of, just in the US, between 35 to 40 million people who are exposed to blockchain and cryptocurrency. So that means a potential of 30 to 40 times as many holders coming into XRP within the next bull run, especially if it's taken over the number one spot. And then we look at institutions grabbing onto it. We look at banks grabbing onto it. We look at the banks now have a legal right to custody, and XRP is the only thing that is legal. And so I think the case for it to climb past that 22 into the 290 range is that once the normies realize there's a new number one cryptocurrency that's only $20 compared to the old Bitcoin that was $70,000, the psychological difference of that is that this is now their FOMO opportunity to get into a cryptocurrency before it becomes $10,000. So I do think XRP can hit 290. I think it could potentially even hit into the thousands within this bull run, because once it is above Bitcoin and it stays there, it's no longer affected by the same market cycle that Bitcoin is. It's no longer on that 4-year halving cycle because we don't have mining, we don't have proof of work. Those things don't matter to XRP. And if everyone is adopting it, now we're just looking at price discovery. We're no longer looking at when is Bitcoin going to turn and bring XRP down with it, because if we sustain the price of XRP above $20, that means we're staying in number one and we don't have a halving cycle.
Can I ask you a question? So with the real USD, is that the name of the Ripple stablecoin?
RL USD, yep.
RL. So I've been thinking about, the big thing with Bitcoin in crypto, what I noticed from just the beginning of getting into it, there are certain things that, like with all these different tokens and coins that are out there that are for sale, there are certain ones, like the only pair is Bitcoin and that, right? Or a lot of times it was Tether and that, right? So you can't buy everything. And so I'm thinking, like, could the real USD be an avenue where, like, folks don't have to use Bitcoin to buy XRP, or, well, I guess now you can just use your regular fiat to buy it anyway. I don't know. I for some reason I was thinking I was onto a good question, but I think it was a poo-poo question, so forget it.
So you're good. So the pairings are important. That's why XRP moves with Bitcoin, and so does everything else right now, because Bitcoin is the most common base pair, as is USDT, right? USDT is going to explode. That's not a question of if, it's when. I had it out with Scam Daddy about this one, but long story short, he got his butt whooped, and I proved that yes, it is going to explode. But with Tether eventually going down, RLUSD and Ripple has announced that they're prepared to have 30 billion in backing out of the gate as they launch RLUSD, and that is about equal to the current XRP backing, and it is right in line with Circle and USDC, and about 1/3 of what Tether has. So as Tether explodes, which is inevitable, people will run to the alternatives. But XRP Ledger, excuse me, I'm running dry. The XRP Ledger is just that much faster and that much cheaper. And because banks will be able to custody it because of Clarity, and nations will be able to use it because of Clarity. And we're also going to have the AMM, which will be that much more functional with a stable coin on the ledger. I don't see any way that RLUSD doesn't become the number one stable coin in quick order. And it will assist also in the XRP pricing. So inevitably, XRP and RLUSD will be the most common base pairs. I don't know how long that will take, but I do know most centralized exchanges will be failing in rapid order, as they've always been, just like the banks. And that decentralization will inevitably win out. because as we do push through XRP, we also have an incoming conservative president who has clearly stated he's against any CBDC. And as he's against that, he's also pro crypto. And I think we'll definitely see the adoption of XRP and RLUSD as very mainstream in American society. But it will also be an option. And because it's an option, and because we have the libertarians and we have the conservatives and we have pandemonium and fear of things like Mark of the Beast and whatnot, and I'm not discounting that. People can feel that way if they want to, and that's perfectly legitimate. But that does mean that decentralization will be the push from the grassroots, and they'll be wanting self-custody in all things, and that's for the best.
Mm-hmm. There's definitely going to be a period of time where there's kind of all things kind of happening at once, right? Like you're saying, those that are just not going to go for this at all and don't want to learn about it, they're going to still have their cash and their regular system.
They're going to do it, and a lot of them are going to either jump in having no idea what they're doing because their bank will custody it, and they'll have the option in logging onto the regular banking portal to swap for XRP or RLUSD, and they won't know the difference, but other people are doing it, so it's cool, so do it. And then there'll be the people that want nothing to do with it, but they're going to see XRP price in the news everywhere, and they're going to see everybody around them celebrating XRP's price as other people are jumping into it as it's in their bank account. And I want to be very clear. I am saying that XRP will not only be a push towards self-custody, but in the interim, it will be in your bank account, not in your centralized exchange, not necessarily in your wallet. I'm saying you will have a wallet in your bank account, whether that's Wells Fargo, US Bank, Chase, whatever it is. It will be attached to your checking and savings. You're going to have checking, savings, and XRP.
It'll be incredible. What do you think, Simon?
All things are possible.
Indeed.
All things are possible.
Absolutely.
Mm-hmm.
Wow. I'm looking forward to a time when it does actually get up there in price. And for all the things that will follow once that does happen. Then those folks that have been holding XRP for a long time, just keep holding on, little roots. Hold on, little roots.
No gain.
Yeah, I mean, you really did like Simon and I always say, the crypto is not for sissies, and you definitely have to have your own views and determination for yourself to know that you've made the right decision. And the more that I study things on my own, and I form my own opinions on different things that I've invested in, I got nobody to blame myself. I feel much more comfortable that way, but I feel very comfortable and calm, and I'm not somebody that has a ton of anything really, but I had my little baby bag goals, and we'll see what ends up happening, and I think it's such an incredible opportunity for anybody that's watching now that hasn't even tried to dip their toe. Man, look into it. Look into XRP. Look into Reaper. All of your projects that you have with the Reaper token, which we've covered on Dip A Toe. For those of you who don't know, we interviewed Patrick Riley couple of different times. I think it's episode 27 and 28, where he talks about Reaper Financial and the Reaper token. And then what we did 28 was Ascension, and then We also interviewed Greg Pruitt for the why am I drawing a blank on that one? What's the name of the one Greg is heading?
Arc Institute.
Arc Institute. How can I forgot Arc Institute? And so there's so many different things that you've created to give back to humanity. And for anybody, if you're going to bother to dip a toe into the space, look into those first and try to understand the concepts of what's going on there. And it's all built on the XRP. They're with the XRP ledger. And it's just you're just a special person, Patrick.
Thank you. You're not too bad yourself.
Oh, thank you. I mean, yeah, it's like I know I talk a lot, but I'm like sometimes I'm speechless when I'm talking to Patrick L. Riley.
Well,
a lot of good things come out of your mind, a lot, you know, and it's been it really is a treat for all of us in this timeline to experience you and your thoughts, your opinions, your creations. You know, it's really cool. I remember history, and you hear all the great minds, and you know, oh, they created this, they created that, and you know, and now here I am years later. Here's a creator of things, of endless possibilities, to be quite honest, and that has the characteristics of those that have come before you, and that is the don't stop, don't quit. I got too many ideas up here, and I got to get them out. You know, and it's really fascinating for me to just be here in awe. Like I too don't stop talking, but magically you've been able to make me shut up, and my wife wants to know how you do it. So, honey, go back and watch the video. XRP price prediction, not price prediction, price call that you were just talking about, the 200 and change there. I'm 100% on board with that. Just based on basic TA. Even at the halfway point, $12 to $15 is a first wave. But you're absolutely right, both of you, in the sense of we hold support at 20. Everybody, now it's easy to go to 100 and then 200 and so on and so forth. You know, so there might be one small moment, a little kiss at 50 and see ya. I'm gonna see if it happens. 6 weeks. That's the clock's ticking. So many sad people about to create, selling too early. Well, you know what?
Yeah.
You know, if you want to sell, go for it.
Sell in So I'm not a financial advisor, but my personal advice is, if you're going to risk selling, sell in increments of 10% of your holdings. If you're going to risk buying, buy daily in increments of 10% of what you want to buy.
Yep.
If you do those two things, you'll save yourself 80 to 90% of the heartache you would usually have as a new person dipping your toe into cryptocurrency.
Absolutely.
Yeah, that's a great suggestion. Like the dollar cost averaging and creating an exit plan if you are thinking about selling. And my thing is, Adrian does bring up a little bit of a point, because I was listening to someone talk earlier today, and they were talking about their story with Bitcoin, and you know, where they first of all, where they were just waiting to buy it and like thinking whether they should buy it or not really understanding what it is. And they wait until everybody else starts buying it. And this is what you were talking about, Patrick, is soon as it starts getting up to $5 and more, people are going to start FOMOing in, because that's the way people are. It's just, I don't understand. Just I was saying it on last week's show, is like nobody was selling their house and buying and getting a new mortgage until the interest rates are up. And now, so like 5 different people I know are like getting a new mortgage and buying a house. And then, it's like, okay, but
psychology. And yeah, when something is more expensive, more people want it. That's the reality.
So true. And so they were talking about Bitcoin, and they were just saying, like, when it was a small price, that nobody wanted it, and in fact, a lot of people just ended up selling it because they didn't really know, and then they look back on it later and think, oh my God, I sold that, I had it. And so, like, this Adrian person saying, people might be getting a little bit sad if they did. If you spent the past several years trying to achieve a certain size bag for yourself for a goal that you met for whatever price point you think it's going to be, if you're one, whether you think it's going to reach $10, or you think it's going to reach $100, or if you think it's going to be $1,000 or whatever, you have those mental goals for yourself. If you spent all of this time and energy holding on, at least give yourself the chance to get your bag to that price point. You know what I mean? And
I would just add that there's people out there that hate TA, and TA is technical analysis. There's lots of people that just hate TA, or they don't understand TA, which is basically what I was just showing with the charts. The reason you do TA is not so that you can perfectly predict the next top or anything like that, because no one is that good at TA, even though I think I'm all right at it. But the reason is to give yourself a target to know this is where I reasonably should be exiting, or where I can reasonably expect to top, so that you don't run away too early and lose out.
Mm-hmm. Mm-hmm.
There's I want to touch on something that you're talking about, Melissa, the people talking about the early days of Bitcoin, right? And they're getting in, and I looking back, man, I didn't know what I was doing, and man, I wish I would have held, right? There's something that the Bitcoin community didn't have then that the XRP community has now. And that is all the evidence that is out there that XRP is arguably slated to have far more utility and adoption at a global level than Bitcoin did way back when. It's far riskier. It was far riskier to be in Bitcoin then than it is opposed to now. It was far riskier to be in XRP back then at fractions of a penny than it is right now. It's probably far more riskier to be out, not in those coins right now. You should probably be in just a little bit. $5 gets you a ride at the racetrack. The other thing is, though, this dilemma I hear all the time, holding forever. And then in the same breath, it's like, well, when do I sell? It's like, well, wait a minute. You should figure out what camp you want a majority be a part of, maybe. If you want or need to upgrade your life, 10% all day, every day, not a bad play. If you're unsure where things are going, 10% all day to get in. It's we don't know where we will be, say, in regards to, is it worth it to you to sell in a year, or is it worth it for you to hold in a year? We don't know what that looks like. But arguably, comparison to where we're at right now and the information that is abundantly out there versus it was 4 years ago, 8 years ago, and so on, you can make a far better solid decision of where you want to be and start creating that plan. As Patrick said, TA is it's not to predict the top or to predict the bottom. It's more or less to give you a good educated guess of going right about here is when I really should be paying attention, and I should have a decision made on what I'm going to do with how much I'm going to do with it, et cetera, et cetera.
Yeah.
Really implementing my plan at that point. That's why people do TA. Where are we today? Where are we at? Where's price action? What's going on in the world? We're taking all this information and applying it to one's own financial plan, even though this is not financial advice, but that's what we're doing.
Yeah. Well, failure to plan is planning to fail.
That's right. Amen. All day, every day, man.
And if you have no plan for what you're going to do in the next bull run with your crypto, and you don't even know what to expect, then you're going to have regrets. That's pretty much guaranteed.
Yeah.
And also people need to realize is that one person's answer to the question is not always the same as the next guy. Because we're all in different places in our life. We're different ages. And you do have to make your educated guesses on where this thing is going to go. And it's going to depend on, how long you hold on, or if you decide to sell something or whatever, how old you are, how much time you got, what are your goals, why did you buy it in the first place? I mean, there's all these questions that you need to ask yourself before you decide to sell something.
And I'd also say, sudden wealth syndrome is a thing, and if most of this audience
that too
is probably holding XRP, and I do think a lot of sudden wealth syndrome will happen, even if you succeed completely in crypto. Your fight doesn't stop there. So I encourage everyone. I just put out a reading list. Actually, there's quite a few financial books included in that on my Twitter. But read Rich Dad Poor Dad. Read Sacred Cows. Understand the difference between what you have and what you're making. Because even if you walk out of crypto tomorrow with $10 million in your pocket you didn't have today, that doesn't make you wealthy. It's not about having $10 million, because you can spend and lose all of that very quickly and easily. Find the ways to preserve it. Go get yourself some rental properties and an income flow, cash flow that is predictable and stable, so that you can have a baseline of your quality of life that you can build off of and leverage. And that's what's going to make you happy in the long run. If you're just looking for money, hoping to get rich, pulling it out and running and buying everything under the sun, I'm sorry, that's not the way it works.
No, it's not. And I would like to add a book to your list if it's not already on there, because I haven't looked. And that is The Richest Man in Babylon.
I have
that one too.
That one still too. That's I gotta add it to my list.
That's like for your type of mind, dude. That's a morning bathroom read, bro.
I have been recommended it a few times, but I'm gonna.
I know you're busy, man. I get it. You're busy. I know he's trying to save the world. Okay, I mean, fine, whatever.
I just wanted to Spencer Jonas. Always enjoy listening to Patrick. I got into crypto space in February and learning lots of new tricks for this old dog. Well, good for you, Spencer Jonas, for dipping a toe and you lucky you that you tripped and found Patrick, because there's nobody better. Adrian has a question here. USDC or USDT or none of these?
So USDC is superior by far to USDT.
That's Circle, right? Is that Circle?
USDC is Circle. USDT is Tether. Tether is a ticking time bomb of bad debt and money laundering and unbacked securities and all kinds of things that you just don't want to be involved with. So I sincerely recommend no one ever put anything of value into USDT. Avoid it like the plague. USDC is relatively legitimate and better, but once RLUSD comes out, that will be the king of stable coins, far and above.
You will have to wait for rollout all over for that, because I was going to say USDC, at least in the short term, it's the safer of the two, in my opinion. But today's hero is tomorrow's villain. And I don't mean that in a negative way. It just means today it's good. Tomorrow it could be bad. And good things are always on the way, which means you have to be in a position to be able to move in that forward progressiveness?
So I'll even confess a little something. I applied to a job.
What?
Yeah, I applied to a job with Circle to be their CFO because I saw the listing for $400,000 a year, and I was like, you know what? I
Hell
could do
yeah,
that.
dude.
But
Was that in Washington?
it's actually remote.
Oh, okay.
So yeah, so I applied, but I was thinking about it, and I'm like, well, if they don't get their butts over to the XRP ledger and put USDC on the ledger, lickety split, they'll be irrelevant within 2 years. So as soon as RLUSD comes out, they're going to kill Circle if Circle doesn't get on the ledger so that they have the cheap transactions at the same speed.
Yeah.
They could do that, but without that, they're toast.
Ah. You are something else, Patrick.
Wait a minute.
Miles.
Time out. We're going to back this boat up. You're telling me you had enough time to apply for a job to be the CFD
And run for president, by the way.
And run for
Just
president,
saying.
by the way. Yeah. And you don't have a time to read a book, Rich Man of Babylon?
I read a lot of books. I just bought it though just now.
Oh, did you? All right, good. All right, cool. Intention is 50% of the game.
Here's another question: is Ethereum safe for the next 2 to 3 years?
I need a
I
definition of safe.
don't know what you mean. Yeah, I don't know what this.
I need a definition of safe.
So I would not bet on Ethereum. I wouldn't personally put any money into Ethereum myself. That doesn't mean it won't do okay. I would still say that there is a law of diminishing returns and that their proof of stake concept after proof of work is not only subpar, but it's not friendly to anybody that is not a billionaire. I'll put it that way. So it has fundamental problems in Vitalik Buterin and Ethereum. Vitalik Buterin, being Ethereum's founder, has always been reactionary. It's always been fire first, fix it 6 months later. And everything he's ever done with Ethereum has always been reactionary to problems. It's never been proactive nor strategically planned. So investing in any kind of product is investing in the people that made that product. And I would say for that reason, Ethereum is not a good investment because Vitalik is incompetent. But that doesn't mean it wouldn't make you some money or one way or the other. I just think it's garbage.
I'm kind of intrigued in it. Like I'm learning, since you know I'm an ambassador for the Chicago coin, and I'm learning about meme coins, which I didn't know very much about it, and I still don't know a lot about them. But one thing that it did force me to do was to I got a MetaMask wallet, which I hadn't had, and I learned that they built it on Base Chain, which is connected to Coinbase, and Base Chain is part of the new super chain, Optimism, which is a collective of folks that are worried. So anyway, I want to study more about these things, and I was going to ask you about it, and that's going to be like a whole nother show to get your perspective on it. But I'm intrigued, and when I did do this, I expected it to cost me a lot because I had to buy the coin with Ethereum, and I had to convert it over to Base and do that, and it was cheap. It was relatively cheap and fairly quick. And so I wonder if that is something that in the future is going to help Ethereum, because if they can, do, I don't know. Cause I was like, I don't know. To be honest, I haven't spent a lot of time studying Ethereum. I just haven't. And, but these are little things that I'm starting to learn now that I at least want to know about. And, so I just wonder if that's a possibility, because I don't think Ethereum's going away. Do you?
I do see scenarios where Ethereum could become irrelevant, archaic, and disappear, to be honest. If the XRP ledger inevitably will add native smart contracts to the XRP ledger, not just EVM side chains.
Yeah.
If that ever happens, which I do think is probably inevitable, I don't know if it'll be anytime soon, but Ethereum becomes completely irrelevant at that point.
Yeah, once everything really gets going on these other,
And I'd say even now, Solana is poised to kick Ethereum from its spot. Solana is more likely to be the go-to main and junk coin, shitcoin blockchain of this bull run, because Solana makes it so easy. You can launch a token in 2 minutes. They have actually a website that's I forget what it's called now, but anyways, you go there and you pay like $2, you name the coin and you drop an image and it launches the coin for you, and then people can invest, and there's literally just thousands of them per day. And it's just ridiculous.
Is it Sologenic?
Solana.
Solana. But I'm thinking of the site though. Sorry.
It's like fun dot something.
No, I'm off.
Pump.fun. Yeah, if you check out pump.fun.
Pump.fun.
That's not suing anything.
Here, I'll even share screen and you'll see how many coins are being created, how quickly on Solana. And this is why Ethereum is not going to be the main coin blockchain of this current bull run. They're just creating any old thing and it just popping up. And
but couldn't it also be too, like, I mean, for some, in some respects, because we are so early with all of this, I mean, a lot of people starting to dip their toe into, like, just even going, be able to do that, right? Like, say, I don't know, do you call that minting your meme or whatever, right? And so, like, I've never done it. I kind of want to try it. And so I think, maybe people are practicing and they're trying and they're seeing what works, what doesn't work, right?
And some of those turn into multi-million-dollar or $100 million junk coins, though. Overnight. So I think the dumb money, if you will, or the high gambling money, or the people who want to get rich quick, Solana offers a lot to those people, the degens, if you will, whereas Ethereum is still very clunky.
I think you're right. I think you're right, Kelly. I'm really, so Kelly says, I think Base is going to be the next Solana. I think Base is going to be big. From the little that I've studied on it already, and also this optimism chain, it's super chain. I'm very intrigued with, but the Base being the up and coming, once that really hits the mass population, where people are being kind of almost funneled to Coinbase, because that's where a lot of people are going to start with Coinbase. I mean, I actually, one thing I will say, that was probably the first app that I downloaded, and it was early on, and I kind of liked it. I don't know if they still do it, but they used to give you free coins. You take the little tests and answer them correctly, and then they gave you free coins. And so, and then once I learned how to use the other exchanges, and so I just didn't use Coinbase anymore. In fact, I tried to log into my Coinbase account, and I think they're making everybody re-verify or something, but it was telling me my 2-factor was wrong, and that they needed my information, like, to re-verify me. And I'm like, maybe I never did KYC with them initially. I can't remember if I had to when I first opened my account. So I don't really know.
I mean, I still use Coinbase. I would just caution anybody that's new to this. You should always be looking to use a hardware wallet or a self-custody wallet. And if you're using any kind of exchange, centralized exchange, it should only be to move money into crypto or out of crypto. You should never be leaving your crypto or your money on that exchange for more than minutes.
Amen.
100% agree.
We got to wrap this up, but there's one last
we do.
question. Drew Anke wants to know, it says Codius, question mark.
So I'm not real familiar with Codius, to be honest.
Me neither. I don't know anything about it.
Yeah, I mean, there's so many chains out there right now. I couldn't possibly keep up with all of them. I do think XRP is the most legitimate for many reasons beyond just the technology. It also goes into the businesses on that ledger, the business that's mainly backing it being Ripple, and its ties to governments and its ties to banks and those types of things. So I think XRP is far and above the most legitimate out there, but there's certainly going to be other blockchains that come along that are worthwhile. And there's nothing wrong with that. But yeah, I did watch, I just want to throw this out there. I watched the FTX documentary by Bloomberg this morning. It's like 2 hours long. It's an absolutely garbage documentary. It's, you know, a leftist.
Oh, thank you for saving me the time, bro. Really, thank you for that.
A leftist news reg with leftist speakers analyzing a leftist criminal who laundered money for leftists in there. It's like the most ridiculous thing. But anyway, on that, I will say that the one thing they did get into, which they were really hitting hard on FTX about advertising and the way that FTX was advertising and, you know, buying the stadium and the Super Bowl ads and all, you know, how they were advertising to people who didn't know anything about crypto and like, how dare they do this? And I'm just sitting there thinking, out of every person holding a 401k in the United States, I almost guarantee I can't find 1 out of 10,000 that can explain their 401k to me logically.
Yeah.
So yes, crypto is going to get there, and those advertisements in that way are going to grow. And as we see that become mainstream, I was thinking about, in that frame of reference, Ripple advertising on the subway in London during Ripple Spell and things like that. Ripple is in a position that as soon as this case is done, they're going to start taking that FTX route if they're wise and advertising big in the US to sports arenas, to, you know, sponsoring teams, sponsoring NASCAR, sponsoring Formula One, whatever. And the success FTX had with that was monumental, and it was genuine success. So that's just another avenue of thought I just want to throw out there. I'm not sure where it even connects, but
yeah. Well, it's just another piece of the puzzle, right? It's another, you know, for adoption and awareness. You know, it comes through advertising, suggestion, power of suggestion. You see a name out there everywhere, whether, you know, or a logo, the subtle logo stuff. It's powerful. I mean, we have been manipulated over our whole lives with that stuff. And FTX, I mean, I can't tell you how many people that I talked to in my personal life where I tried to get them interested in crypto at all, to try to buy Bitcoin or buy anything, right? And nobody wanted to do it. But there was that one ad during the Super Bowl that, like, you could scan it. And I'll be damned if a bunch of people I knew didn't scan that. And it was the first time they ever had any kind of interaction with anything crypto related. And I had been asking them for years to do it. I mean, you know, it's just the way it is. So you unleash XRP, Ripple advertising and stuff, or anything, you know. I mean, this Chicago coin thing that I'm involved in, where there's a possibility that we're going to be in a movie, you know, and you start getting some of those actors and stuff, and they're going to load it on there, and it's going to be the talk, and it's going to spread, and it's going to be wild. to watch it happen. I'm gonna see it. I'm gonna see what happens. Like, you know,
Yeah.
the power of this,
Mm.
and so we'll see. I don't know, but well, gosh, Patrick, Simon, got any final questions and thoughts? And
If I do
I
that,
did.
we're
I
gonna
did
be
not
here for another
expect.
2 hours.
Oh my God!
If I start talking, we're gonna be here another 2 hours. So I'm gonna save it for next week.
Yeah. We thank everybody for coming.
Thanks
There's
everybody for
8.
checking out the show. 823 eyes on the prize. Patrick, always a pleasure. Always a big pleasure.
Always a pleasure, and thank you for having me. I appreciate you
You're
both
always
very
welcome.
much, and God bless.
God bless, brother.
Thank you guys so much. Have
Thanks
a great
everybody.
rest
Y'all
of
have
your
a good night. Make sure you got your floaties on because it's Dip A Toe. Let's go.
Bye, guys.